Good afternoon. My name is Marek Pawełczyk. I am Vice Rector for Science and Development of the Silesian University of Science and Technology. It's my great pleasure to welcome you at the university. We wished the rector of the university welcome you. However, he is the president of the board of the Conference of Rectors of the Polish Universities, and due to a sudden meeting, he is unable to join you right now. But I believe he will join us in a while, and he will say a few words also to all of the guests. Let me first introduce the conference. We started yesterday and we had a very interesting discussions about the activities of the priority research areas. And today is the second day, which is performed fully in English due to a number of outstanding guests who were invited to this meeting. At the university, we had several preliminary meetings over the last months, which allowed us to accumulate the knowledge which is at the university and which was spread over a number of unities and faculties. Let me give you a short introduction to the university just for the guests to be better recognized in what we are doing and how we are operating. I would like to welcome you in our campus. However, due to the pandemic situation, we are unable to invite you and to be on site. But I believe that in the near future, we will be able to meet at the university and you will be able to see our beautiful campus and our infrastructure. The Silesian University of Technology is a research university. In fact, we participated in a competition organized by the Ministry of Science and Higher Education. And we started in that competition together with other 19 universities. Due to a thorough regulations related to that competition and evaluation performed by an international board, we are selected one of 10 leaders in this competition in Poland. And we got that status for 7 years. It gives us very unique opportunities because we got very special funding and very special other possibilities to participate in a number of programs. You can see a picture from the ceremony which was in Warsaw, where our magnificent rector, Professor Arkadiusz Mężyk, got a diploma from the hands of the Ministry for Science and Higher Education. And since that time, we started working very extensively to further develop our university for the university to be a real research university well recognized in the world. And also recently we got a status of a partner in a European University Consortium. It was another competition where the Silesian University of Technology, together with 6 other universities in Europe, participated. And we got a very special program, which is very much promoted by the European Commission. We believe that taken together these 2 programs, our university will flourish in the following years. At the university, we in fact have 13 faculties and 2 institutes. You can see the names of the units. As you could notice from the list, we are in fact a technical university, but not only, because very many other subjects are being concerned. I think that hearing to today's panelists, you will be able to recognize what in fact our activities are. You will notice that they are very much oriented also to the societal knowledge and also to human awareness. When preparing for the research university, after a thorough analysis, which in fact took place for 18 months, we finally defined priority research areas. We have 6 priority research areas. The first one is computational oncology and personalized medicine. The second, artificial intelligence and data processing. The third one, materials of the future. The fourth, smart cities and future mobility. The fifth, process automation and industry 4.0. And the sixth, climate and environment protection, modern energy. The activities in those areas were presented yesterday. Today, instead, we are going to have panel discussions where we are going to raise subjects which are fully up to date, which are sometimes very thorough or very outstanding hypotheses, which need some verification, some awareness. I believe that you will actively participate in the discussion and will observe the fruits of this discussion and the activities in following months and years. When defining also the goals for the university, when working on the application for the research university, and also when working on our strategy, we concentrated on something which we believe is most important. We want the university to operate as a research university fully recognized in the world. That's why we need to orient to top quality research and also to involve this research in societal challenges to improve living standard and economy. We also want our staff members to well develop their careers. The careers should be based on excellence development, and also we would like to pay special attention to the young. We believe that the future of the university depends mostly on the approach to the young. We want to also offer modern education motivated by real problems. That's why our connection to the real world and to the industry and civic environment is very much important. We also would like to extend our international collaboration, and which is very important because of the recognition of our achievements, but also together with industrial involvement, it allows the university to fully use its competence and also to get very good partners which will help our university to further develop. When being a leader in the Polish universities and when obtaining the status of a research university, we got very special funding. The funding is in fact a huge amount of money, which is to be distributed to our main goals of the university in 7 years, from 2020 to 2026. But we were quite original, in fact, when we decided to spend this money mostly for investing to the human capital, both researchers, the staff members at all, doctorant students and students. That's why you can see on this slide the main spendings of the funding. So you can see that we would like to also make some institutional upgrade, but the most money are dedicated to scientific excellence, to modern education, to internationalization, and also to staff promotion. We decided to undertake some measures for a rapid development. So it requires, first of all, a remarkable mobilization of the entire university community. That's why we are working in the priority research areas and the first meetings, which I mentioned. In fact, they are not first because very many of them happened so far. So they've proven that the mobilization is really huge, that people from different faculties, from different fields want to undertake interdisciplinary activities and want to work together. That's why we also need partners from outside the university, partners from scientific units, partners from industry, from the civic environment, and from the international community to help us develop and also to use our competence. We want a strategic partnership. The strategic partnership is to perform projects together, to have some other measures, but also to learn from the others. When working on the application, in fact, we contacted several research universities in Europe, and we try to gain the best what they have, how the universities are being organized, and how to use this in our organization. And we are going to continue such kind of activities, and we are going to also invite other research universities to this management body to help us getting information what is the most successful in the organization. We want to offer extraordinary investment in excellence. This is what I said in the previous slide when I presented the funding. And I mentioned several times about our huge interest in being combined with the societal and economy and environment. But we are not only offering our knowledge, we are also offering our thorough expertise, we are offering our infrastructure, we are offering our units who are ready to help when preparing for the projects together, to establishing some centers, and also responding to rapid responses to the request, just to be a university which is really helpful to the socioeconomic environment. We want to really respond to the societal needs. That's why it is important to incorporate these needs not only to the science, but also to our education, which we are trying to be as modern as possible. That's why at our university, the problem and project-based learning are very much interested. And we are offering very many to them, even up to 200 a year. We also very much engage in dual studies. We are a leader, a country leader in that. We offer a flexible study track. We organize PhD school jointly with research institutes, and we are also mostly concentrated on collaboration with industry when performing the doctorates and with international collaboration. The number of student scientific associations which we have at our university, I think, says a lot, because there is no single university in Poland who has a similar number of student scientific associations. At our university, in fact, there are about 180 of them. Many of them are very well recognized, not only regionally, but also in the country and also in the world. Many of them receive very prestigious scientific awards. So we invite all the active students to participate in our research because in fact, operation of the student scientific associations and also performing the project-based learning activities is incorporating students into research and also together with industrial collaboration, because many of the student scientific associations and that projects are in contact with industry and also in the real world. We, as the university, offer many tools and many possibilities to help the others who want to take advantage of our potential. At our university is Project Management Center, which helps the university and also helps the other who want that help together in collaboration with the university. We have regional contact point for EU programs, which is for 2 regions in Poland. We also have a very special unit at our organization, which is the Center for Incubation and Technology Transfer. It is dedicated to respond to the needs of the industrial partners and to the society, and also to spread our achievements. I would like to thank you very much for participating in today's conference and also for joining. And I believe that the discussion will be really fruitful and will be very helpful for all of us to further develop. I also strongly encourage you to participate in the discussion. The first day was, as I mentioned, just to present our activities in priority research areas. And today we have a different organization. Today we have panel discussions. And each panel discussion is dedicated to one of the priority research areas. And the first one is personalized medicine today and tomorrow. So thank you very much for joining one more time. And I would like to give the floor to the moderator of the discussion. Please introduce yourself and the panelists. And I wish you all of you who participated very interesting sessions. Thank you very much.
Thank you very much for a nice introduction. My name is Ewa Piętka, and I have a pleasure and an honor to moderate the session. Welcome everybody to the session on personalized medicine today and tomorrow. Let me just briefly introduce the idea of the personalized medicine, which is a medical model, in which medical decisions, practices, interventions, and products being tailored to the individuals are based on the predicted response or risk of disease. Initially, diagnostics has been employed for selecting optimal therapies based on patients' genetics content or other molecular analysis. Currently, the concept has been extended and may be applied to new approaches in healthcare. And it is based on the dynamics, and it's employed in prevention, diagnosis, therapy, rehabilitation, physiotherapy, and even home care. At the current session, 4 experts of various research areas will share their experiences in the field of personalized medicine. And it is my pleasure to welcome them and introduce 4 professors. Professor Krzysztof Składowski graduated from the Medical University of Silesia, worked in the field of oncology and oncological radiotherapy in various research centers or universities in London, Houston, Los Angeles, Wisconsin. Currently, he is a director of the Maria Skłodowska-Curie National Research Institute of Oncology. He is also a national consultant in the field of oncological radiotherapy. At our university, he is a member of the advisory board. Professor Marek Łos studied medicine at the Jagiellonian University. He obtained his PhD from the University of Heidelberg, habilitation in molecular medicine from the University of Münster, and currently he pursues various research projects within the area of regenerative medicine, biomechanics, biotechnology, oncology, and targeted cancer therapy. He currently is the director of the Biotechnology Centre at our university and holds an honorary visiting professorship at Jinan University in China. He's also a senior scientific advisor in Linköping in Sweden. Professor Marek Kimmel graduated from our university. Currently, he is a professor of statistics and bioengineering at Rice University in Houston, with a joint appointment at our university. He's also a director of the doctoral program at the Rice University. He collaborates with research centers mainly in the United States, France, Germany, United Kingdom, and of course, Poland. He currently is his research interest is focused on computational models of genomic evaluation in cancer. And Professor Marcin Grzegorzek studied at our university, worked scientifically in the area of pattern recognition in Erlangen, London, Koblenz, Siegen. Currently, he is a full professor of medical informatics at the University of Lübeck, Germany. He is specializing in machine learning methods for medical application, and also he is a member of the advisory board at our university. Personal medicine as a concept that is based on understanding the diversity of symptoms, severity, genetic traits in various patients suffering from the same diseases. Some people with no comorbidities suffer badly from cancer or different viruses, for example, COVID nowadays, whereas others do not feature any symptoms. And I'd like to ask Professor Składowski, what makes patients' disease resistance so different?
Thank you very much for the invitation for this very interesting session. I'm very happy to be here with you and to share the problem of personalization in not only in medicine, but especially in oncology. Why? Because oncology was in the past a special example of unpersonalized medicine, rather. Compare, for example, to diabetic diseases, where we have a lot of drugs, a lot of therapy strategies. In oncology, those strategies were, and in fact still are, based on 3 main modalities of the treatment: surgery, radiation, and chemotherapy, which is now very quickly developed as a growing part of oncological therapies. And therefore, our army dedicated to fight against cancer was rather small and modest. Therefore, we need a lot of new drugs, a lot of new modalities for diagnosis. And in fact, and nowadays, we recognized our cancer diseases normally specified as a localized origin, as a lot of diseases at the same organ. For example, the field is very growing in breast cancer topic, in lung cancer, what is very promising now in oncology, because this disease is mortal and very unpleasant to treat. And of course, many others like gynecological and urological diseases of neoplasms. So I think myself that the personalization is very fruitful in the future because, in fact, each patient with cancer has his own or her own disease. And is it means that everyone needs different treatment? We don't know. But the practice shows that it happened. It happened very often and practically in our clinic now. The second problem is that treatment for cancer is time-consuming. It's not only a one procedure like surgery, but also a long procedure taking weeks or months, like radiation and chemotherapy. And the question is, does disease over the treatment is the same like before the treatment? Is our biomarkers still active or still useful as a basement for decisions which should be able to take over the treatment? This is my question, and I personally believe that we still need very carefully monitor the patient and try to discover new biomarkers, which could be important not only before the treatment, sometimes completely not before the treatment, but over the treatment, and base the decision to change the treatment, to replace some drugs, to escalate the dose, for example. That's my short opinion about this problem.
Thank you very much, Professor. And now continuing the line of thinking and reasons of problems with the personalized medicine, let me ask Professor Kimmel, how is the bioinformatics and computational biology may support the personalized medicine in cancer prevention, diagnosis, and therapy?
Let me say that I appreciate being invited. Sorry for these hiccups. So I will limit myself to listing some topics in which bioinformatics and computational biology can be helpful in personalized medicine. Well, first of all, bioinformatics is meant to manage large data sets obtained from different platforms, which obviously are very complex, and they are also very different for each of us. And so this variability is something that that we are facing in chronic diseases such as diabetes that was mentioned here, cancer, cardiovascular diseases. Everybody's different. Now, so in face of this data, of this wealth of data, which cannot be reviewed manually, it is necessary to develop algorithms that visualize and review this information, and then try to summarize this information in a synthetic form. So such as trees, topological structures, and all sorts of visual depictions. All these are tasks of bioinformatics, sort of preparatory tasks for personalized medicine. There are also some other aspects, for example, understanding what is the molecular diversity in a given population. Obviously, each of populations, say in Europe, that underwent, that had this very complicated history of population movements and changes, everybody's somewhat different. And lung cancer in Poland is different from lung cancer in China. Then, another one of the main tasks is help to develop molecular classification of diseases to direct treatment. So there are various cell types and also various mutations that govern chronic debilitating disease, lifetime diseases, and the treatment, the extent of the treatment, the possibility of intervention varies given this background. Now, so that was something like bioinformatics, what is called bioinformatics. There's also computational biology, which has a pedigree stemming from mathematics, physics, but is enhanced by computational power that we can achieve these days. And so I will mention two topics which are important. So first of all, based on these mountains of data that bioinformatics is processing, we can produce predictions, mathematical statistical predictions of the course of disease and the treatment. And one of these simplified examples might be, not so simplified, but let's say understandable example, is the ever-present question of how to predict relapse in chemotherapy of leukemias. So there is a metric which is called minimal residual disease, and nobody knows how to use it, how predictive it is. And it has been object of disputes for maybe 20 years. That's the problem is universal, how to be able to predict the outcome with some certainty. Another issue is to develop models of cancer progression, which will tell us how long ago the disease started when you discover it. And so also solve an inverse problem, namely how early we should start looking for a given disease in individuals. So this modest list of topics characterizes our involvement in personalized medicine. Thank you.
Thank you very much. Now, let me ask a tricky question to Professor Łos about the personalized medicine. Is it a holy grail or a sneaky evil? What I mean, do we need to limit the scientific development? And if yes, what are the self-imposed limits or even legal issues that we have to implement and we should implement?
Thank you very much for inviting me. So based on the presentations of the information provided by my predecessors, clearly, as Professor Składowski mentioned, the more information we are achieving about the cancer, the better we can treat it. We gain also the realization that the cancer is also actively responding to treatment. Whereas Professor Kimmel clearly indicated that the amount of data that we are collecting and requires help with computational help to analyze it properly. And indeed, the short answer to the question could be that it could be both. It could be holy grail and it could be sneaky evil. So the holy grail is to provide the best possible, the best patient-tailored treatment for each patient. To get that, we require a lot of data. We will require genetic information of the patient. This become with the sequencing of human genome, and about 20, so a little bit over 20 years ago, and with the genome sequencing, which is becoming more and more inexpensive, more and more affordable, we are able to gain a lot, and I mean really a lot of information, which require the technologies that Professor Kimmel mentioned to properly assess. Now, the problem is that those information can also be used for evil, for not for inappropriate causes. So you could imagine that, for instance, ambitious chief financial officer of a company decided to acquire on dark web large chunks of personal genetic data of a population, and then decided to hire and fire people based on that data. Of course, it is so he would hope that hiring people with certain genetic background or genetic traits would bring a benefits for the company, would cause less sick leaves and so on. We can dispute if this would really have a positive effects, financial effects for the company, but clearly such situation will definitely lead to abuses, which I think are not absolutely not permitted in our current society. So therefore, I think it's very important. Is very important not so much to limit the study of human genome, the study of the biology, but it's limit the access of the information to our personalized genetic data, to our personalized genomic information. Because if this information gets into wrong hands, it can be actually very harmful for the society. So I had my own personal example with that. About 14 years ago, in one of the neighboring countries, I was trying to get a private health insurance, and because of my a little bit high body mass index, I was denied that. So there is already the evil side to a certain extent is happening in our society, and only proper legal guarding of the human of the information about personalized human genome will be able to, in my opinion, prevent those abuses. Thank you very much.
Thank you very much, Professor. Thank you very much. Up to now, we have addressed the personalization issue in the area of medicine, biology, and bioinformatics. Let us extend the scope of personalized medicine to personalized healthcare and unify prevention, nutrition, physical activities, maybe rehabilitation technologies, in order to first prevent the possible disease, or in case of previous illness, after the recovery, can we adjust personalized activity in order to make the patient return to a normal, active life? And this is a question to Professor Grzegorzek.
Thank you very much for introduction. Thank you very much for this question. I liked very much the example where Professor was. I'm living in the neighboring country you meant, and I had the same problem 3 times already. So knowing that this medical investigation is going to come, I was like going for jogging for 8 weeks so that my BMI is okay. But it shows that it doesn't make any sense, right? So I'm working with artificial intelligence, and I'm mainly working with part of artificial intelligence, which is called machine learning. So we learn on examples from the past, from known examples from the past. And in this way, we can support different decisions in the whole health process. Yeah? How does it look like nowadays, you know, we human beings, we produce a lot of data. We have wearables, we have smartphones, we produce really huge amounts of data. We have some medical history, we have some microbiome data, we have some genomics, we have some phenotype data. So all this data can be brought into relation with some kind of medical condition. And this is on the one hand very interesting because of course you can like look into the future. You can, for example, compute, having enough examples from the past, you can compute a certain probability that someone is going to become a metabolic syndrome in 5 years, like diabetes, one example, with a probability of 80%. On the other hand, it's kind of hiding a lot of ethical problems. So the big benefit of artificial intelligence systems is that they are able to learn on the examples on the one hand, but at the same time, this is kind of a drawback because if the systems have learned on these examples, the complicated machine learning algorithms work like black boxes. So basically, at the end of the day, you can investigate them and you can kind of make sure, or you can check if they work correctly or not. But you cannot really be able to understand why they are providing a certain decision support. Yeah, and from the legal point of view, especially in the medical domain, it's not that easy. I mean, every decision in medicine should be somehow understandable. Although, on the other hand, when we, for example, think about some drugs and the process of investigating drugs is kind of also a black box. One area that, in my opinion, is already very important and will be more important in the future is an area of personalized nutrition. So we are collaborating here at the University of Lübeck with an Institute of Personalized Nutrition. And what I have learned from them is that, you know, this kind of dietary recommendations cannot be provided to the whole population. You should be very specific. Some people react to potatoes very bad, like, for example, me. Potatoes basically are like sugar in my case with regard to my blood sugar. Some people react to fats worse. So what I've learned is that based on the data that we have about the human beings, the mentioned the human-based data, we can produce and generate using artificial intelligence algorithms. We can generate automatically or semi-automatically recommendations for nutrition plans with regard to a certain medical condition, for example, migraine or metabolic syndrome or obesity and so on and so on. And I think, you know, I wasn't kind of believer. I thought, well, another diet will not make you healthy. But after I've investigated this stuff with them in the last year, and also I've made an experiment on myself, I think that you can really influence a lot of things with changing specifically according to your data, your nutritional plan. The same is, of course, for physiotherapy and rehabilitation, so the area of movement. It is not true that everyone should have exactly the same kind of physical activity plan. You have to be very careful and you have to look at all the different data that people have. So generally speaking, our health system is kind of getting more and more problems because we have an eldering society. We have more and more metabolic problems in the society. I think prevention will play a much more important role in the future. Thank you.
Thank you very much. In the first round, we've considered advantages and limitations of personalized medicine today. In the second part, we would like to consider on the challenges and features of personalized healthcare in medicine, biology sciences, bioinformatics, and computational oncology, as well as artificial intelligence. So let us start with the second round. What challenges lay ahead of medicine to facilitate the development of readily available personalized medicine? And this is the question that goes to Professor Składowski.
This is a big question and a very difficult answer because in fact the challenge is ongoing every day. Each patient wants to be treated effectively and with success, and expect that our treatment, our procedures will be focused on him and directly dedicated to his disease. Of course, we know a lot about many diseases, of course, cancer diseases. And success is that our drugs are developing very fast now. Many pharmaceutical companies deliver every month a new, not only new drugs, but also treatment strategies for based on molecular dedications. Immunotherapy, for example, is the example of very fast growing the field of cancer treatment. So the problem is that, and the challenge, big challenge, especially in Poland, is that those therapies are normally and usually very expensive. And this is a big problem for reimbursement of those treatment strategies. Some of them are approved in many countries, but not still in Poland. And this is a big problem for our doctors. But frankly speaking, now we have much less problems than 5 years ago, for example. The next question is that the cancer is changing. For example, cancer and biology of cancer who relapse after the treatment, after not sufficient treatment, could be not the same like primary one. And sometimes we have no data and no knowledge. Is it treat those patients in the same way or try to develop new treatments, especially in the field of pharmacotherapy, because surgery and radiation is rather uniform modality of treatment, and main differences between surgery 1 and surgery B is that could be accent or using some microscopes or robots, for example. In radiation, we can manipulate with dose, time, and energy, and kind, for example, of radiation. So the challenge is big, and is going every day in our hospitals with our patients, and the solution, simple solution, how to manage with this challenge is observe the patient, be careful with his symptoms, with any important informations which are could be used for the clinical practice. Thank you.
Thank you very much, Professor. And now let us have a look at the biological sciences. And now is the question to Professor Łos. What are the challenges that have to be faced in the problem of personalized medicine?
So as Professor Składowski mentioned, so every patient seeks and deserves the best possible treatment. So it's our role as biotechnologists to try to make this treatment available and affordable. So the challenges ahead are many, but I think we could group it into three categories. So one of them would be quite high costs, sometimes really prohibitive costs. Like for instance, the currently available effective immunotherapy in leukemias that Professor Składowski mentioned, the so-called CAR-T therapy, could cost between $75,000 and $750,000, depending on the country and the course used. So on the positive side, the costs probably will go down as we rapidly develop new methods. For instance, to introduce pharmacogenomics, we needed to sequence the human genome. So in the past, it was required a whole institute for that. Nowadays, the whole transcriptome could be sequenced for under $500,000. And of course, methods which under development, like for instance, machine learning, which other colleagues on the panel has mentioned, will make it available to go down with the costs. Will probably make it more and more affordable with the time. And the third aspect, very visible in the case of current pandemic, is the social acceptance of and social barriers of those of new treatment. So there is a significant group of people that are hesitant to get vaccinated because the currently available vaccines against SARS-CoV-2 have been developed very fast. So it's development of vaccines is considered to take years, whereas pharmaceutical companies came up with procedures that allowed to have them with under 1 year. Two of the vaccines are currently in use, so-called mRNA-based vaccines, never used before, and obviously there is a social hesitance to have those vaccines. So proper information campaign and proper interaction, explanation to the society, engagement of the society will probably be able to break those barriers. So I would like to stop here and give the chance to respond to others.
Thank you very much. Thank you very much, Professor. And now let us address the challenges and limitations to be handled in the bioinformatics and computational biology. Professor Mark Kimmel.
Thank you. There are many challenges, almost exclusively challenges. But anyway, I try to mention three of them, which I like most. And they are among the most difficult. So one of them is to understand progression of diseases and developing models that would inform population-based policies of prevention and early detection. So watching your sugar seems to be quite simple, but actually setting a boundary between normal variability and something that threatens real disease, real diabetes in this case, is much more challenging. Similarly, in early detection of cancer, we can try to screen by, let's say, chest X-ray or chest computer tomography, all the smokers, but this is extremely costly. And then when we detect something that looks like cancer, but is very small, then should we expose the patient to risks of surgery? So there are challenges here, and they can be on population basis. They can be solved only by using statistics and similar methods. So the other challenge that is ahead of us is how to integrate markers from different platforms. So one specific challenge that exists in interpretation in cancer data, cancer molecular data for a particular patient, is the interrelationship between gene expression, gene methylation, and copy number variation. These three variables are intertwined. And how to resolve which of them is the underlying cause of abnormality is an interesting problem and unresolved challenge. And finally, the third one, which hasn't been discussed here a lot, and there is a real weakness here, is to achieve progress in computational design of new drugs. So this is more like computational chemistry, in which one is looking at targeting larger molecules, such as proteins, by smaller molecules, such as drugs. And this might reduce, well, currently a cost of developing a new antibiotic, say, is around $800 million. And most of this cost is going for 100 compounds which were tried but rejected. And this process can be, of course, made computational and reduce the costs. So I think that these are among challenges that are that I see on my side of the equation.
Thank you very much. Personalized medicine extended to personalized healthcare, as we have noticed, necessitates the demand for a fast and reliable technology able to acquire and process multiple data and deliver the results to in the user-friendly manner at the time and place where the information is needed. Artificial intelligence is recognized as a research and development frontiers. Now, Professor Grzegorzek, what is the limitation, or are the limitations and challenges in the area of artificial intelligence?
Yeah, thank you very much for this question. The main limitation has been already mentioned by me, is that the artificial intelligence supported decisions in medicine are not understandable to us. So once we've learned, usually, once we've learned the algorithms based on data, nowadays we're using very complex neural networks, for example. We are estimating maybe 15 or 20 million different parameters. So theoretically, this is at the end of the day a deterministic function. Practically, you cannot really say why for a certain input vector you get a certain output parameters. And these black box algorithms make it, at least in Germany, very unlikely that those systems will take over certain decisions fully automatically. One answer to this problem is the so-called explainable artificial intelligence. So there's a whole bunch of research activities where people try to develop machine learning algorithms, artificial intelligence algorithms in such a way so that they can really understand why a certain diagnosis has been taken, on which parameters, on which markers have been the most important ones. And this is giving us a great opportunity for the collaboration between IT guys like me, artificial intelligence guys, machine learning guys, and the medical domain, life science domain, because we can somehow use the tool of artificial intelligence to understand this. I call it a gut feeling of medical doctors. I mean, you know, theoretically, all decisions are taken because of some rules and so on. But practically, a lot of experience is playing a role. I mean, if a medical doctor in a small village has been seeing patients 30 years already, he probably knows immediately when a patient is coming with, for example, a sinusitis, inflammation. This is it. Yeah. But if you ask him, how did you recognize it? He doesn't know. So the idea would be, in this case, this is just an example. You would then install sensors that are mimicking, like kind of simulating the sensors he's having, like maybe a microphone, maybe some cameras, maybe some other sensors. You would mimic the same scene, you would acquire the data, and you would have the label. So first, you would just kind of build his gut feeling again, artificially. Later, with using explainable artificial intelligence, you could look into this artificial intelligence algorithms and maybe understand on which parameters this decision actually has been taken. What was the most important aspects there? So I think the black box problem of artificial intelligence in medicine is on the one hand a very big legal and ethical problem for the time being, but knowing that researchers are working on explainable artificial intelligence very much now, it might even turn out to a big advantage, so that in the future we will be able to produce new scientific findings in medicine somehow based on these algorithms. Thank you very much.
Thank you very much. Thank you very much, Professor. Okay, let me just summarize it. Experts in many research areas indicated the importance of the personalized approach in various disciplines, including medicine, biology, computational oncology, computational biology, artificial intelligence. All the requirements related to the development of the personalized medicine can be met through the cooperation of multidisciplinary team of partners. Patient needs are recognized by experienced physicians who collaborate with scientists and engineers and develop the goal of the research that would satisfy the functional requirements of authorized medical staff as well as overall healthcare system for the benefit of the patient. We cannot skip, of course, here the legal issue and the ethical problems that also have been mentioned. Many of these areas are recognized as research and development frontiers and employing new technology in the clinical environment. Technical support that improve the standard of living and make it safer and more comfortable are also required in here. Just to summarize and to finish it, thank you very much to the speakers for presenting their expertise, and thank you very much to all participants of the panel discussion. Thank you very much.
Thank you.
Thank you very much for the invitation.
Thank you very much. All the best for you.
Thank you.
Thank you very much, Professor Piętka. Thank you very much, Professor Kimmel, Professor Łos, Professor Składowski, and Professor Grzegorzek for the outstanding discussion. I appreciate also that you kept the time, which is very important for fluent progress of our session today. I think that there will be perhaps opportunity to ask questions at the end of today's meeting, but if there is one from the audience, I would like to ask. Is there a question, please? I cannot see right now, so thank you one more time. And if you could stay with us to the end, it would be a pleasure, I think, to hear also the other discussions. Thank you again. So it was the first discussion, which was entitled Personalized Medicine Today and Tomorrow. And we are now proceeding to the second priority research area. And the title, it's really challenging. It's Artificial Intelligence in the Wild, the Big Data Problems or Big Problems with Data. It's a question mark at the end. I'd like to kindly ask Professor Paweł Kasprowski, who is the coordinator of the priority research area, Artificial Intelligence and Data Processing, and is going to moderate this session. The floor is yours, and I also wish you a very, very interesting discussion, and I also kindly ask to keep the time. Thank you.
Okay, thank you. And welcome everybody on the second panel discussion. As Rector already said, it's the panel devoted to the second priority research area, which is artificial intelligence and data processing. My name is Paweł Kasprowski, and I'm the coordinator of Silesian University of Technology priority research area number 2, artificial intelligence and data processing. My research interest includes data mining and deep learning, especially when it's concerned with eye movement signal processing, because eye movement signal processing, that's my main objective of research. And let me now introduce shortly all the panelists. First of all, I'd like to welcome Minister Michał Boni, I don't think we need to introduce him because I think everybody knows him, but to be specific, he is a Minister of Administration of Digitization. In fact, he was the first Minister of Administration and Digitization in Central Europe. He is also former Minister of Labor and Social Policy, member of the European Parliament of the 8th term, and currently he's a member of Supervisory Board of the Open Dialogue Foundation. And taking the topic of our today's discussion, he's the author of the very interesting report, Artificial Intelligence and Governance Going Beyond Ethics. The second panelist is Professor Władysław Duch. Professor Duch is one of the founders of cognitive sciences in Poland, and he is the head of the neurocognitive laboratory in Nicholas Copernicus University in Poland. He is former Deputy Minister for Science and Higher Education in Poland, former President of the European Neural Network Society Executive Committee, and well-known specialist on development of neurocognitive informatics. The next panelist is Professor Janusz Kacprzyk. He represents System Research Institute of Polish Academy of Sciences. He is full member of the Polish Academy of Sciences, and he's an outstanding specialist in the field of fuzzy logic and decision support system, as well as evolutionary programming and neural networks. He is foreign member and fellow of a number of international and national societies in Bulgaria, Netherlands, Belgium, Finland, and so on. He was awarded with several Dr. Honoris Causa degrees from foreign university, and it's my great pleasure to invite him also as a member of the International Advisory Board of our priority research area, Artificial Intelligence and Data Processing. The next panelist is Professor Jean-Charles Lamirel. He represents University of Strasbourg and Lorraine Research Laboratory in Computer Science and its application. He's also a lecturer and invited C-Sky full professor at DUT University in China. He's a committee member of the main conference in data mining, and one of the 3 foreign members of Special Committee of Science and Discipline Construction in China. He's also a member of the International Advisory Board of our priority research area. The next panelist is Cesar Ignacio Garcia Osorio. He's an associate professor at Universitat de Burgos in the computing department. He's a specialist on instance selection, big data, data mining, and visualization. He's coordinator of the Admirable Research Group, very admirable name, by the way, principal researcher in several regional and national projects. And he is also a member of our International Advisory Board. And last in alphabet, but definitely not least, is Professor Andrzej Polański, chairman of the Scientific Council of Technical Informatics and Telecommunication at our Silesian University of Technology, and former director of Institute of Informatics at our university. He is a specialist on bioinformatics, various areas of mathematics applied in biology and medicine, as well as system theory, problems of stability and control of dynamical systems. He's an author of over 150 publications, cited over 1,500 times. He teaches courses and gives lectures in several universities in Poland and abroad. So as you see, we have very interesting panelists, so I hope the discussion will be very fruitful and very interesting. The topic of our discussion is very broad: artificial intelligence in the wild and the big data problems or big problems with data. But in fact, I would like to narrow this topic a bit and talk about the responsibility for artificial intelligence. And thanks for Professor Marcin Grzegorzek for introducing this topic, taking the topic from medicine, because it is the problem. It's not only the problem in medicine, but also in other disciplines and other areas. And today I want to ask our panelists the question, who should be responsible for artificial intelligence errors? And I will start with the obvious example. Let's say the autonomous car hits the tree. Autonomous car driven by the artificial intelligence. And now the question is, whose fault is it? Maybe it's the fault of the driver who was warned that he should keep the wheel and be aware and be careful. Yes? Maybe it's the fault of the producers of the car because they sold the car. Maybe it's the problem of the IT company that produced the application, the model that was used to steer the car. And maybe it is a problem and it is the fault of engineers that worked on this model. They started the model. Maybe they are not working in the company. The company just used the model that they produced, and maybe it's their problem. So it is an important question and becomes more and more important today. So I will like to ask Minister Michał Poni to start the discussion.
Thank you very much for the invitation, and thank you very much for this excellent idea to organize this conference on research priorities and artificial intelligence. I have listened to the previous panel on personalized medicine, and it was very, very inspiring. So congratulations. Additionally, I want to say that now I'm related to SWPS University in Warsaw, in Department of New Technologies in Social Applications. We have established this department, and this is my real focus now. You have put the question, which is, as a case, very easy, but the response, the answer is very complicated. So I will start with a discussion on artificial intelligence in the European Union, and model in which we need to discuss about artificial intelligence and risk-based approach, because it is crucial for better understanding and also coming back at the end to the liability problems. So we know that there are some completely non-risky applications related to artificial intelligence, non-risky physically and mentally. So they should develop and be disseminated freely. But there is something which can be named pyramid of risks, from some potential for harm via regular or significant potential for harm via serious potential for harm, and at the top with untenable potential for harm. Those last cases should be probably banned. So what is important to understand that vis-a-vis those relevant level of risks, the responses should be clear from the legislative, institutional, and business perspectives. It means that there are some requirements which ought to be addressed to all creators, engineers working on artificial intelligence products and services. The essential is, it was raised during previous panel, to avoid the asymmetry of information between producers, providers, and users. It requires to take care on the principle of explainability, which means address proper information to the users, institutions responsible for certification systems, representatives of insurance companies. It is important for the liability system, and scientists. The information should discover the mechanisms of functioning of artificial intelligence, avoiding the situation to have artificial intelligence as a black box. But this is the first step, because when we want to avoid some critical incidents, we need also to discuss about not only on this risk-based approach, but also about some procedures which are important for impact assessment. And there is a big discussion in the European Union, and traditionally and conventionally, in relation to machines, to tech products, there is a procedure of ex post impact assessment. in the current debate on artificial intelligence, it is raised very strongly to prepare and make it obligatory the procedure of ex-ante impact assessment. It is new, and the scheme of ex-ante impact assessment should be related to ethical issues, to the fundamental rights, and also there is an idea to establish the model based on human rights impact assessment addressed to some levels of risk of artificial intelligence, or as many countries in the European Union are supporting, addressed to all solutions. When we will have those solutions, risk-based assessment, and those ex-ante procedures, it will be, of course, easier to discuss about liability systems. I can say now that there is no clear option, that there is a discussion, and probably in this complicated model as the autonomous car, it should be discussed the share model of responsibilities, because this is not only the responsibility of engineers creating the artificial intelligence. This is not the responsibility of driver in the situation in which driver is sitting aside. It is not only the responsibility of the producer of cars. So we need to discuss further to find the solution. But on the other hand, we need to combine the relation, which is important for the impact assessment, to fundamental rights, and combine those relation and those solutions with consumers' rights and with clear redress mechanism, because it is clear. And when we can look at many devices functioning in the European Union and directives which are organizing the life and the functioning of these devices, there are many clear points which are indicating the liability model. So this is the first voice in this discussion. Thank you.
Thank you. Thank you. Any more comments, maybe? Okay, Professor Duch. Professor Duch is here as Paweł Kasprowski, but don't be mistaken. I'm not into two persons. Just.
Yes. Well, somehow the link got lost, maybe through the filters. Well, I want to say that AI is maybe not so special as some people think, because for people in computer science, AI is simply trying to solve problems that don't have efficient algorithms to solve them. So anything that requires intelligence and knowledge to solve it, because there is no explicit algorithm, is requires intelligence. So we use AI for this. So it's more like mathematics, let's say. And then applications of AI are like any other software applications, but they're very diverse, and we have to be very careful asking questions. Okay, should AI be regulated? Autonomous cars should be regulated. I don't expect them to be on the roads soon, for a very simple reason that to control the car, you need to practice. If you have automatic support, you'll stop practicing, and then requirement that you grab the wheel and do something when you have no experience is going to, end in a crash. So until we'll have a really foolproof solutions, I don't expect that there will be any way to really release that on a large scale. Many applications, as Minister Boni has said, many applications are not controversial. For example, the protein folding, recent Google Fold, which has made such impressive results. Application in music, arts, lots of other things. So we have to be careful where we want to regulate anything related to AI, and there are definitely many areas like that. Thank you.
Thank you. Maybe for people not used to artificial intelligence, maybe I just do a short supplement. Why the artificial intelligence is not explainable in many cases. 10, 20 years ago, when, let's say, the car hit the tree, we could analyze the code of the application and say, okay, it could be, the programmers should add one condition here, maybe change a loop here, and it would work. Yes. And now we have a network, very deep network with millions of weights. And in fact, we only can say, oh, probably we should train the network with more images of tree, something like this. Yes. So it's the main problem. And of course, as Professor Grzegorzek said during the previous panel, we want to go to the explainable, explainable solution. But the problem is that people cannot explain that their activities as well. Yeah? Because he named it gut feeling of a person. Yes, it's good.
We have to regulate people.
Yeah. We cannot regulate people, so it may be difficult to regulate this.
But on the other hand, we need to give them rights. Yes, also rights, for example, to disagree with some solutions, and this is the line for consumers' rights.
Yeah, that's right. That's right. So the question how to regulate everything. Maybe the idea which I suggested, maybe we should I don't know, restrict the access to the research, something like let's say when students of civil engineering or architecture at our university finish their studies, they have a very long way to learn until they may develop bridges, for instance. Yes? When students from medicine finish their studies, they have a very long way to operate somebody. When our students are working on the second and third year of their studies, and I remember my student who showed me on his laptop how he controls refrigerators in Starbucks in New York, because he was doing such a project. Yes? So we don't have such certificates. What do you think about it? Maybe Professor Polański will say something about it.
Okay, so thank you for inviting me and for this participation to this session. Well, actually, I would like to relate to previous participants. I think Professor Duch is right that artificial intelligence is a part of science. It is actually maybe a part of mathematics and nothing special. However, it is inevitable, I would say. As engineers, we understand that artificial intelligence improves productiveness, improves economy, reduces risks, yes, improves safety, economy. So it is already around us. We are surrounded by applications of artificial intelligence. We are crossing gates in airports, yes, and there are automatic systems for proving our personality. I think traffic lights in our city and in many other places are controlled by artificial intelligence applications. So clearly, artificial intelligence is improving, is surrounding us, is taking a lot of power. And clearly, we all understand that artificial intelligence, despite being so important, has a lot of risks together with it. And I think Minister Boni has made a very, very nice introduction showing us some legal issues related to it. So I think we are afraid on one side that artificial intelligence can become very risky by slipping out of the control. Maybe it is not going to happen very soon, but in some military or police applications, it's really frightening. But I think more realistic risks are already happening, and they are very, very, I would say, it is called sometimes mathematical destruction. Yes, artificial intelligence is controlling our job opportunities, our education, our access to credits. And it makes, and I think there are a lot of voices that it can contribute to the conservation of exclusion, social exclusion mechanisms. Yes, it creates a lot of risks, like related to violation of privacy of people. Yes, so we also see a lot of risks and a lot of damages, misusing, overusing of artificial intelligence, which is already happening. And I think we should kind of, majority of us panelists, and I think participants to this event are engineers. So I think we should try to understand this. And in my opinion, answering your question, the creating mechanisms of development of artificial intelligence, reasonable development, includes very close cooperation between authorities, between lawmakers, between, say, industrial societies, and between us, engineers, and experts in artificial intelligence. And actually taking or finishing my contribution by a concrete remark, we have started the course on data science a few years ago. And maybe we, taking into account what is raised in discussion presently, maybe we should take more attention in teaching students, which are already graduating these courses, legal issues and ethical issues. This may be, taking all this discussion to us, we should probably pay more attention to these things. Thank you.
Thank you. Professor Osorio, please.
Yeah, I would like to share an obvious reflection about artificial intelligence to add to the discussion. Artificial intelligence is not good or bad per se. All depends of the uses we do of it. It's the same as in other cases. Biology can be used to advances as the ones we are watching these days with the new RNA vaccines, but it can be also to create biological weapons. Rocket science has put the man on the moon, but can be also to be used to launch nuclear warheads. So the same is for that's my Spanish, for artificial intelligence. There are good uses and bad uses. And another issue we could add to the discussion is that are all of the researchers evaluating the models properly? Because I think a lot have been done in the last years to establish accepted evaluation frameworks for the models, but I'm afraid that there is a lot of work to do in this area. Also, most of the models are being used as black boxes without fully understanding all the details of why they are working, as pointed out already in the previous panel. And it comes to my mind those examples of deep learning models for image recognition, where the predicted label can be changed just by changing a single pixel in the input image. So here, I also see an area to which more time should be dedicated, and that we'll have to better decide who should be made responsible of the bad results of artificial intelligence.
Yeah, that's right, yes. I think Professor Kapczyk, yes?
Okay, thank you very much for the invitation, first of all. And I think that I have much less doubts in this area. Because why? Because, you know, I think that, first of all, in artificial intelligence is can be viewed from different perspectives. Like we view it, what Professor Duch mentioned very correctly, like a part of, let's say, intelligent technology that let's say, solve some problems which were reserved for human capabilities, let's say. But functionally, it's something like a tool for better decision-making or problem-solving in difficult situations. But if you look carefully at this, what is going on in these areas, not in our area, in the areas like psychology and so on and so on. So you have something like this. There is a so-called ADM, automated decision-making, and you have quasi-ADM, actually quasi-automated decision-making. So basically, ADM is something which happens with artificial intelligence in very simple cases, like, for instance, debt awarding in banks. Very simple cases, because you can do this in an automatic way. In practically all other cases, which are not trivial, you have to use humans' judgment and expertise. And in my particular case, I don't believe that in the future we can foresee there will be anything like a automated decision making for non-trivial tasks in which we will use the artificial intelligence. So I think that in such a case, there are two responsibilities. First responsibility is that there are some let's say, rules, practice, and so on, used, let's say, or followed by designers and by those who implement the ideas. And then at the end, there is a human being, like a driver who maybe does not drive all the time, but he's responsible. And I think that the human being will always be responsible. Thank you very much.
It's a huge problem with human beings. Then when they have a tool, they forget that they should be responsible for this tool.
Of course.
So
lawyers will always,
especially when the tool is working well for a long time, the person forgets that it may fail. Yes?
I have been married for 45 years, and I must say that the neural networks in the brain of my wife are completely unpredictable.
But on the other hand, if I can add something, when we are discussing about different various levels of intelligence, of artificial intelligence, I think that we need to raise the problem of accessibility of qualitative data, because we are training the machine learning models, the algorithms, the artificial intelligence. So this is very important, what kind of basic data are delivered to artificial intelligence, because you have mentioned those pictures of trees, yes? It is very important if there will be completely related, for example, to the part of the year, spring, winter, or something like that, or not. Yeah? So I think if we want to avoid some misused activities of artificial intelligence and automated decision-making models, so we need to start with the discussion about accessibility of very qualitative data.
Yeah.
If I may add, I mean, we don't have medical data in Poland, for example. In Germany and other countries have very big programs related to genetics, scanning, neural data, cardiological data. We've tried 3 times to get some money to establish a certain repository with my colleagues at the Warsaw Technical University. And all those failed because the money went into scanning old journals and newspapers. Well,
that is a broad topic for another panel, I think.
Yeah,
very broad topic.
But I think the problem is that actually sooner or later we will establish these data repositories. But the problem is whether this data should be available to your employer or to your medical environment, and what algorithms are used to kind of make decisions on your future and circumstances.
Yeah, and I think the main problem is what Mr. Boni mentioned, that our models are mostly data-driven now. Of course, when the model works, some theory, maybe I'm wrong, but I think that when the model works, the theory is created why it works. But at first we have data, and then we take this data. It is a famous example. You probably know it, but maybe not everybody knows it, about the U.S. Army. When U.S. Army ordered the model that distinguishes tanks in the forest, yes, from plain images, and the model was perfect for the data they gave to the company. They bought the model, and it occurred that it doesn't work because they gathered data. One day they gathered data with tanks, and another day they gathered data of the forest without tanks. Yes? So one day it was sunny, another day it was cloudy. So the model just learned how to distinguish sunny and cloudy, and not times. Yes.
I think
So
it's a technical problem, but I believe it has been solved about 5 years ago when the generative adversarial networks came, because now everybody is using that, and the situation where changing few pixels are going to change dramatically the classification of objects is gone. This has happened a few years ago. Everybody is invoking that. Oh yes, I mean, it may be manipulated, but with the guns, when you actually introduce another network that tries to fool the first network, and the first network learns on this distorted data, that doesn't work that easily anymore. About 20 years ago, I've written a paper showing that the decisions of neural networks may be actually improved if we add distorted data, add some Gaussian blur to the data, etc., and then look at the decisions and visualize these decisions. Then we may be quite sure that even larger distortions are not going to do something very strange with the decisions. So there are techniques. It's technical problems, and here we're discussing more fundamental problems.
Yeah, sure. Of course, there are ways to avoid all these problems, but generally, my question is, because we want to have perfect artificial intelligence that is perfect, that makes decisions in a perfect way, and when anything fails, it is a problem. It's a huge problem. Yes, I listened to the speech of Stuart Russell once, and he said, when we have a robot that prepares meals for children at home, let's say, we will have such a robot, and the robot says, oh, there is no food in the refrigerator, and prepares meal from a cat of this family. It would be the end of the artificial intelligence in the world. Yeah? But the problem is that people also make mistakes. Yes? So maybe we should allow artificial intelligence to make mistakes. Maybe artificial intelligence, for instance, is better in recognizing images than people now. These complicated models are better, but they are still not perfect. And suddenly the car hits the tree. But people hit the tree as well. So maybe it's better. Right? What do you think about it?
And nobody says that we should prevent people from doing the work they are doing, because sometimes they do mistakes, right?
Yeah, but where those mistakes are between people, between humans, it's easier to find the solution. Not easy, but easier. But there is a problem of interaction model between humans and artificial intelligence in many forms, yes, many formats. So this is a question, and this is a real challenge. So the discussion how to avoid those critical incidents is based on the thinking that we need to prepare, for example, as I have mentioned earlier, this ex-ante impact assessment to minimize the threats related to mistakes. But of course, it will exist probably because of many reasons.
I think I got something from chat from Professor Lamirel, yes? Because I got something from Paweł Kasprowski, and you seem to be another Paweł Kasprowski.
Yes. What I want to point out, do you hear me?
Yeah. Yes.
Okay, what I want to point out is that for years, artificial intelligence learning is based on risk minimization. That means that we accept that there is some risk in learning. And if we accept that there is some risk in learning, it's because we also accept that we are dealing with some outliers data, okay? Data which are not, looking like, you expect they look for. So that means that also, in some way, this kind of technique, which is also the one we use in deep learning, is prone to also generate some problem in learning and also in reaction of the AI system. So I agree with the fact that if we accept to make the learning working in such a way, we also need in some way to have some explainability process for AI, and this is becoming more and more mandatory, because in the case we are facing with this kind of specific situation or in which data are not looking like you expect the system expect to look for. Okay, the system is misclassified or misbehave. So if there is no user in the front of the system that can understand the system decision, and maybe take an adverse decision to put the situation going normal, you are facing problem, and this is very well known. And this problem is well known also, in plane accidents. Okay, in plane accidents, most of the time, so the accident came from the fact that there is some wrong or erroneous data or coming inside the process. And so, but the system is not wrong. The AI system are not easy to work with that. So this is a big problem, because if there is no interface with user to escape from this situation, the problem will not be solved.
Yeah, well, it's an interesting point of view. Yes, that's maybe right. Do you have any comments? And I would like to get back to my previous question, maybe about this responsibility for researchers. I observed, because Professor Duke said, okay, the problem of adversarial attacks is solved. Yes? Okay, it's maybe not solved, but maybe. But when we are using guns, it's more difficult to do this kind of attack. But there are many ready-to-use models that are not using guns, just for like ResNets and so on. And all these models are vulnerable to adversarial attacks. And it's very easy to use this model for my application. Yes? And anybody can use it for application and say, I'm using artificial intelligence. Yes? And now the question is, maybe we should specifically say that you cannot use this model if you don't have knowledge, I don't know, certification or something. I don't know. It's just a question. Maybe it's not a good idea to restrict many things, because if we restrict, we reduce development. But what do you think about it?
I see some problems there. The problem with the AI, and the good thing about the artificial intelligence, is that the pace of advancements are too big. I mean, and in the other side, in the regulation side, it's a slow process to make a new law. It's a very slow process, and I don't think the regulators can keep the pace of the advances of artificial intelligence. So that's a problem there. And another thing is that there are the expectations about artificial intelligence sometimes are too big. As in the beginning of this panel, the artificial intelligence is not something that special. But the thing is that it's a attempt that come out to the society in general, and even just as a marketing technique. So sometimes the people put the level of artificial intelligence in products that have nothing to do with artificial intelligence. So there is a problem of the regulators being too slow and the perception in the society of the artificial intelligence.
But if I can add something, yeah, because of course regulators are very low, but on the other hand, only in the European Union, this discussion about artificial intelligence, risk-based assessment, and how to use and how to build the principle, the rule of explainability, and also the liability problems. and all of those ethical dimensions, consumers' rights, and so on. It is also raised during the discussion, and the European Commission will present probably at the end of this week or in the next week the new proposal on this. I agree that we need to keep attention because we need to open the innovation. So very strict rules could kill the innovation if they will be too strict. But the composition between the proper framework related to human rights, fundamental rights, and consumers' rights, and on the other hand, the best practices, composition between the legislation and activities of all partners. I have talked with representatives of some months ago, and they have created some kinds of social dialogue council. And when they are ready with some new products, they are inviting representatives of civic organizations, consumers, scientists, engineers, and they are discussing. This is some kind of ex-ante assessment, and they are discussing about possible effects of the solution. So I think we need to go this way. To find the proper rules, legal rules, and on the other hand, to make much more strongly.
Professor Kacprzyk, yes.
So I think that these two opinions were very important, but I think that Professor Garcia's opinion was very good for me because what he mentions is that there is a big progress in artificial intelligence, and what we have now is a so-called AI skill gap and AI talent gap, and so we need very, very fast the best people. But and that's why a certificate means time, but it must be serious, Of course, you can give everybody a certificate, but it means nothing. I give you an example of where some older people know what was the martial law in Poland in the beginning of the 80s, and I spent martial law in America, at many universities. And what happens when I was living in New Jersey, and there was a Polish population, and there was my cousin, very close cousin, who was a medicine doctor. He was a very rich man, and there was also a civil engineer who was also very, very rich, And then I went to a very good university like even Princeton, and Columbia in New York, and then MIT, and I saw so many very good people, Chinese, in the School of Medicines, in the civil engineering department, and so on and so on. So I asked them, listen, why are they going there to work? Because their salaries are much less than the salary of a practicing doctor or a civil engineer. And they told me, of course, they were right, because if they wanted to be a practicing doctors, they would have to spend like 6 or 7 years, like volunteers without any money. If they wanted to be a practicing civil engineers, they would lose a couple of years, And I think that this is the main problem. If there is a dilemma. First of all, either we give a certificate like for free, for everybody, which is very easy, and these people don't lose time. They start working, or we give serious certificates, but it takes time, and these people will not wait. And also the industry and then business and industry, they need AI people, they will not wait. So I am a little bit skeptical because this is a difficult aspect of certification. Thank you very much.
Thank you. The main problem in this discipline is that it's changing rapidly. Yes? For instance, if I want to give, a certificate for using TensorFlow library, the last version of TensorFlow library is from the last year. So and next year there will be something completely different. So it is
the problem maybe is if you give right people with a certificate, it could be complicated to control that they are the skill that are needed to dealing with AI system is also meaning dealing with data. Okay, that means most of the time the people that deal with AI must be data scientists first. So they must be able to understand which kind of data they could feed in the system to make the system working correctly. And this is a huge problem because that means that they have the skill to understand, how to balance, the data in order the system is working correct. So I'm not sure that the people are really all able to, have the necessary skill to make it. And I think it's a more central problem. Yeah.
But this is a question for professors who have to teach them properly. I just can't imagine how this could work. I mean, unless the priest gives you a certificate that you're an ethical person and you can then produce AI applications, I mean, how can we do this? I don't think so.
It's complicated, yeah.
Okay, we must finish. It's a pity because the discussion is very, very interesting, but we are almost behind time. So let me just summarize with a simple example. I had on the conference in London several years ago, one of the CEOs of the companies said that 100 years ago in Great Britain appeared newspapers. And in these newspapers, there are a lot of photographs of known people, lords and so on. And these people were not very happy that their photographs are appearing in the newspapers. Some of them decided we must ban newspapers. Newspapers are wrong, bad. And others said, okay, we cannot ban it. It's not possible, but we may regulate it somehow. Yes. And I think we are in, let's say, more or less similar moment of the artificial intelligence. Artificial intelligence has a lot of advantages, changes our lives, but on the other hand, we must be sure that we go in the correct, proper direction. Yes. So thank you very much for your participation, for your interesting point of views, and hopefully see you on the next conferences, because it's just the first conference.
Thank you for the invitation.
We are just starting. Thank you. Thank you.
Thank you very much.
All the best to everybody.
Thank you.
Bye.
Thank you very much. Let me remind you that the subject of the session was artificial intelligence in the wild, the big data problems or big problems of data. It was moderated by Professor Paweł Kasprowski and participated by Dr. Boni, Professor Duk, Professor Kacprzyk, Professor Lamirel, and Professor Ignacio Garcia Osorio and Professor Polański. Now I'd like to kindly invite you to another sessions, which is going to be moderated by Professor Przemysław Data. And Professor Data is the coordinator of the Priority Research Area 3, Materials of the Future. And the title of today's panel discussion is Smart Materials, Challenges and Opportunities. Professor Data, the floor is yours. Please invite and introduce the panelists. I wish you thank you so much.
So first of all, I would like to mention in relation to the previous talk, there is no big problem with data. So I hope there is no big problem with data. And from that point, we can go forward. So we'll talk about materials now, materials of the future. So the topic is smart materials, challenges and opportunities. Like you know, now we have a lot of smartphones, we have smart TVs, everything tries to be smart. So also with materials, there is new challenge to create new materials which are actually smart. And we'll try to investigate today or try to answer the question if there is a reason or need for smart materials, and if there is how to approach this area. We have, okay, it's changing. Great. So we invite several speakers to discuss this topic. So first of all, about this discussion, if you have any questions, I'm talking to the audience. If you have any questions, simply ask directly, or raise your hand, or write on the chat, and then I will try to repeat your question. And Wait a minute. Okay, now it's, no, I tried to check to see a chat and my presentation, it's a little bit difficult. Okay, so if you have any questions, simply ask or raise your hand. And as for the speakers, we have speakers, we invite the speakers from the three main area of the research today. From the topic of the ionic liquids and carbon nanotubes, or generally carbon nanostructured materials, and also perovskites. Why? Mostly because those are currently hot topics, and in all those cases, there is a huge demand for smartness in those materials, or multi-sensitivity properties, multi-applicability of them. And we'll try to answer this question based on those materials. As for the discussion panels from the Silesian University of Technology and our priority area 3, I invited Professor Anna Chrobak, who is specializing on synthesis and characterization of novel ionic liquids for different application, catalytic application, but also for the batteries and other organic electronics application. And also Professor Sławomir Bonso, who is specializing on carbon nanotube synthesis and applications. Like both of them presented yesterday, their cooperation with the industry. And as for, we plan also today to tackle this problem from industrial point of view. The next speakers are Małgorzata Światła-Kwaśnik, and she's also specializing on the synthesis and application of ionic liquids and multifunctionality and the hybrid type of those ionic liquids. And Professor Paweł Trosin from Institute of Problem of Chemical Physics, who is specializing on also synthesis and application of organic materials and hybrid semiconductors for molecular electronics. And especially since a couple of years, he's working he very promising results on the perovskite materials and derivatives for solar cell application. After next speakers are Professor Alexis Rusinek from University of Lorraine, who is specializing on dynamic behavior of materials and structures, metal polymers, and numerical modeling. From the industrial point of view, we will see the approach of the talk from Dr. Ronald Kalb, who we already had opportunity to hear and talk during one of our meeting with the companies in February. And he will talk about this ionic liquids application in the industry and if there is any smart applications there. Our last panelist is Professor Krzysztof Kozioł from Cranfield University, and he's also a founder of two companies, Cambridge Nanosystem and Chemetics, which specialize on the development of two-dimensional materials, mostly graphenes. So that's for the invitation of this panelist, and I think the best would be if all the speakers will turn on their microphone. That would be easier to talk, I suppose. And as I told, if somebody will have questions, simply raise your hand or ask. As I heard, unfortunately, Professor Kozioł have only 30 minutes, but we'll try to. So maybe I will ask him directly as the first question. So, as I said, we would like to talk about smart materials. Smart materials are, I would say, difficult to synthesize. They are expensive, much more expensive than normal materials. So, from industrial point of view, is there a demand or reason to implement such smart or synthesize or sell such smart materials? From if you are talking about carbon-related or 2D-related materials, what do you think?
It's very good to see you, Przemysław, and thank you for having me here on this panel. we are talking about smart materials, I think we have to ask ourselves, what do we really mean by this? And when I am talking about smart materials, I'm talking about materials that are capable of serving multifunctional applications. So if you look at that, you might think that actually it might be worth to really properly think about the material and designing the material, because actually down the road, it can save you quite a lot of costs. And I'm working a lot with composites. We are designing the next generation of smart composites. What it means is that we want from this composite to be able to generate some power, being able to take the turbulences that we are experiencing more and more in the air, but also to be able to take lightning strike, that is there. And what do we do currently? We use carbon fiber, we use copper, which is very heavy, and we put fuel and batteries in these kind of structures. So could we make materials that will be able to combine these different functionalities and really serve as one? And I think it is it's very important to make sure that we make this design properly, that we plan how this material would look like, what would you require to make this material, but also to plan this design and future manufacturing to make it sustainable. So I think it's no longer the question of whether we can make smart structures and materials, but they have to be made sustainably in the future. We cannot sort of make mistakes of the past that we focus on making lithium batteries without thinking where the different elements will come from it, from what would be the origin. So we have to think, I think, also not just smart, multifunctional, but also sustainable. And I think that is a key thing for us to really plan properly. So I think that's my take, Przemek, on this. And I'm welcoming people to come forward with comments.
I think that this is very important to think about the sustainability, because there is a big contribution of smart materials in the development of sustainable society, and it is always really big problem to find the common sphere between the society, economy, and green chemistry. So those materials will be expensive, yes, but they are with the high added value, I think, and they can also, we should think about the facing the EU goals in greenhouse gas emission reduction, but in the meanwhile, we have to think about the promoting of economic recovery and growth. So altogether, smart materials, I think they will help us to do it, yes. And what I found also interesting, in 2003, the government in Great Britain ordered the research concerning the future of smart materials. And they predicted that the key to the 21st century competitive advantage will be the development of products with increasing level of functionality. Of course, this is the role of smart materials. And what was interesting, they also predicted that they believe that the adding functionality is the way to offer the best opportunity for the UK industry to compete with the low price imports. So the materials with big added value will be expensive, but we have to think about the sustainability, of course. And I think they have a very big future. Yeah. I think that we lost Przemek.
Okay. Anna, if I can just add on the cost aspect that, I'm not quite sure that smart necessarily means expensive. I mean, obviously, the industry likes to use that word to generate more profits, but does it really have to be expensive? You know, I don't necessarily see that that's the case. You know, we can properly design materials that they may still, you know, be really multifunctional, serve various functions, but not necessarily that they would have to be so expensive. And you know, we are, for example, looking at strategies where you know, our raw materials for some of these materials that we are making are waste gases. You know, we are going back to the basic sort of feedstock, which can be quite cheap, and of course we will put high price if we can sell, you know, expensively, but they don't really have to be that expensive. So not necessarily I would be worried about, you know, the price tag behind it. What is important in my view is to make sure that they really work, that they really serve the function that they are supposed to, they add the value, and that they are made in a sustainable way, I think.
Okay. I think we lost Przemek, so maybe Roland will tell us something more from the point of view of industry.
Yes, I was already about, can you hear me?
Yes.
Yeah. Okay, I was already about to raise my hand. And I would like to hook up on the last comment. I think that's really one of the, let's say, one of the big troubles that everybody connects smart with expensive. And this is not necessarily true. I absolutely agree. Probably I start with a ridiculous example, yeah, of a very cheap smart material. Everybody knows greenhouses, right? Also private greenhouses, and those greenhouses have windows, which nowadays open automatically by a small actuator, which is filled with a hydrocarbon oil. I don't know if you know these devices. They are, of course, this is not in industry, but it's a mass, very cheap material, a mass application. You do not need a sensor, you do not need electricity. It's just an actuator filled with the right type of an alkane with a high thermal expansion coefficient, and it opens your window and closes it automatically for a very cheap price. This, in my way of thinking, is a smart material for this application. Yeah, of course. I'm talking about ionic liquids, and also here I personally see at least 3 to 4 fields which will be extremely important in the future, and this will be transport in the future. I mean, thinking globally, this will be water. This will be grid energy, and this will be the future of manufacturing, which will all cover, of course, the problems which we have on this planet. And for example, I'm giving an example on ionic liquids where we are working on. This has a big impact on what we are currently doing at ProIonic. Giving the example of producing advanced biofuels, so biofuels of the second generation, where we use raw materials from agricultural waste, which is done, for example, at the Joint Bioenergy Institute in Berkeley, where I'm working as well. Ionic liquids are coordinative. Ionic liquids are just the best way to pre-treat this type of lignocellulosic biomass, better than everything and anything else. It's just the absolutely gold standard of pre-treating biomass in order to deconstruct it, separate the fractions, depolymerize it, and ferment it to diverse chemicals and platform chemicals and fuels. The problem, of course, is that ionic liquids are pretty expensive. And if you use them for pre-treatment of biomass, you have to recycle them to a very high extent to be competitive at all. And so a normal ionic liquid cannot be distilled, as you know, because the vapor pressure is literally 0. There is a new type of ionic liquids which are known for several years now, which are so-called switchable ionic liquids or distillable ionic liquids. And yes, in reality, there are this new type of ionic liquids, which is very much cheaper than the old one, works perfectly well on this system where you have an amine and you apply CO2 pressure and you form an ionic liquid in situ. You pre-treat your biomass, you separate after the process the pre-treated biomass from the ionic liquid, and you release the CO2 and you are able to distill and purify the starting amine. So this type of, probably you would not call it a material, I call it a material. Yeah? This is an enabling technology in order to decrease the price of the pre-treatment process, which is one of the biggest parts of the economy of such a type of biofuels. You can bring down the price by a factor of 10, and you can recycle it. Starting material is cheap, and you can split or turn on or off the ionicity of the ionic liquid just in the moment where you like it by pressuring or depressuring using CO2. So this is one of the strategic tools used to bring down price for this type of advanced biofuels down to a price of less than $4 per gallon, which is the target price. And without using this technology, by using ionic liquids, you are almost without any chance. Using this technology makes it possible. So this smart material, which can be switched on and off whenever you like it, is cheaper than the state of the art and works perfectly well. And this is the new state of the art right now. And there are a whole bunch of examples where other ionic liquids and other materials, of course, there are not only ionic liquids in the world, of course, where this will gonna be playing a big role also in lithium-ion batteries, also in manufacturing, where we can replace nasty chemicals against new chemicals, where we, for example, can replace the distillation of water by upper or lower critical solution temperature material, which splits into two phases on exceeding or on being down to a certain temperature. So for desalination, for example, we are working with such things. And so I could go on and talk, but I'm not taking too much time. But definitely clear, the world and the industrial world needs smart materials in the future. There is no doubt. We have to put all our power we have in science and find new ways for these big topics in order to be effective, less harmful, greener, and so on. So I'm absolutely convinced that this will be an important point for the future. And now I stop.
Thank you very much. Yeah, thank you. Sorry, somehow I lost internet in my office. I moved to my cell phone, smartphones, as we are talking about smart materials and smart things. But I'm back. Professor Trosin would like to make a comment. So, Paweł, if you would like to say something.
Yeah, thank you so much for inviting me to join this panel. I'm really happy to be a part of this very important discussion because from my point of view, smart materials, it's our future. So they really gonna make a revolution in material science because smart materials are supposed to be not just multifunctional, but they're supposed to be stimuli responsive. And in that sense, they have a lot of new key applications which could revolutionize our life. And I just, first of all, I want to say that I fully agree with the comments given by the previous panelists. And I just want to add few, let's say, comments on the key application areas for smart materials, of course, from my perspective. And I want to say that smart materials can play essentially important role in life sciences and actually in two areas. One area is related to the smart healthcare and actually smart drugs, which could really be revolutionized in a way when we would be able to control not only the, let's say, rate of the drug delivery and pharmacokinetics and dynamics, but also we could control the targets of the, let's say, treatment. So we don't just inject drugs and wait until it makes some effect on the whole our body, but we deliver drugs specifically to the tumor or to the other tissue which we want to heal, and we induce the treatment effect by the external stimulus. So there is a huge progress in this area, but I'm quite sure that it can evolve further. And another important area is related to the regenerative medicine, where we are really looking for the scaffolds for living cells, which could be used to produce some real artificial tissues. Because currently the existing polymers, up to the best of my knowledge, they are sometimes not really good mimics of natural skin, for example, or other natural tissues in terms of mechanical properties, in terms of, let's say, the functions which they induce on the living cells, which are, let's say, integrated with these polymers using, for instance, 3D bioprinting. And that's, I think, a kind of very important area where we could achieve a huge progress. And finally, I strongly believe that one day we will be able to print artificial liver or artificial, probably even artificial heart. Of course, that requires quite some development. But I strongly believe that that's possible. And since I work with in the field of electronics and energy storage and generation, I would say that there are also huge opportunities in these areas as well for smart materials. And in the area of electronics, I think that we are going to enter a new phase of the development of electronics. I mean, of course, we all know about wearable electronics, but I'm quite sure that like in a few decades, we will have electronics integrated everywhere on our skin, on our clothes, and here smart materials could play an essential role because we could really induce a lot of functions, and there are very nice demonstrators like smart materials which provide a controllable injection of insulin in diabetic patients, for example. And that's one of the key areas which can also be developed. And with respect to energy storage, I would say that smart materials are really required now. It's like urgent need for smart materials which would enable self-healing function for battery electrodes, for example, or for battery electrolytes, especially solid electrolytes. Because currently, I mean, everyone knows metal ion technology, lithium ion, and also some post-lithium technologies like sodium ion or potassium ion more recently. But all these batteries suffer from relatively short cycle lifetime. And that can be actually fixed by developing self-healing electrode and electrolyte materials. And I'm quite sure that that might be very, very important area for the future development. And in photovoltaics, which is like my primary research area, I would say that we have a very nice example of perovskite photovoltaics. And perovskite solar cells are so much successful because they represent, I would say, the first example of photovoltaic devices which are based on self-healing semiconductors. So on the one hand, perovskite are very unstable. They degrade very fast on the action of everything, light, temperature, ambient species. But at the same time, they undergo very fast self-healing. And this fast self-healing enables unprecedented defect tolerance and restoration of the device characteristics. And I think that it's just the first example, an evolution in the area of photovoltaics focused on the development of self-healing semiconductors can bring really a breakthrough in this area as well. So that's my comment. So sorry for being a bit long, but hope that.
No, it was really interesting, and I completely agree with such statements and explanation. I have so what Professor Rusinek thinks. Do you where do you see application of smart materials? And actually, as you are also modeling or predicting, can you predict responsive materials, or the smartness of the materials, or different properties?
Yes,
what do you
yes, I will try to answer to your question, but just a comment, because I'm not thinking all the example we discussed before by the previous speakers that we can call it smart materials. For me, smart materials is not exactly the same. You can call all your example, for example, structural object, smart objects, smart structures, but it's not materials. For me, as I'm working in material science, materials mean a piece of steel, a piece of copper, a piece of single materials, but it's not the case. Now, if we want to speak about smart material, I think we have to define it in a different way. Every time will be a composite. If I'm taking, for example, a piece of steel, it will not be a smart material. If I'm taking a piece of copper, it will not be a smart materials. As, for example, shape memory alloy, because we will have two phases in shape memory alloy. We will have austenite, martensite. And what will give the smartness to the material is mean it will react to a stimuli from external stimuli. For example, it would be a field of heat, of temperature, magnetic field, electric field. But this will give the smartness to the materials. And maybe we have not to call it a smart material for each, all cases you discussed previously. When you connect material to structures after you add some batteries, I think it's more object, but not a smart materials. But maybe because I'm not from the field, I'm just from material science and this metallurgical aspect, I'm not using the same word. But now to answer to your question about the modeling, of course, we can try to model all the material we are using, but a constitutive relation by itself will be available to define the material when you apply a stress or, I don't know, different pressure, different temperature. But now if you are acting the smart material with some electric field or magnetic field, for example, for ferrofluids, we cannot consider it in the modeling or constitutive relation to predict the material behavior itself, because it's not really a material behavior. And really, I have no idea how to do it. If now you will ask me to model the behavior of a piece of steel, a copper, or what you want, it's possible because it is really of the material itself. But now if you are combining several material itself, it will be first a composite, and if you will add some wire, electric field to activate some position, some rotation, or some movement, we cannot consider it in a model or constitutive relation as it's defined. For example, we have now we have 3D printing materials. Also, we can produce very smart material with 3D printing. But if we are just printing polymers, for example, or metals, it would not be a smart materials. But if we are printing a wire with some carbon black particle inside, of course, if we will apply some current, electric current, we can activate this polymer. But if we are just printing a 3D printing materials with a normal wire of polymer, it will be just a simple materials. But it's just my point of view about the definition we are using for smart material or not.
No, I completely agree with you, and the definition is exactly the same, simply the approach, because you are engineer, we are more chemists, so the approach to understand that it's a little bit different. But what was explained before, it's more the effect which you observe using smart materials like in perovskites. It's the response of cell fillings during the photoactivation of the structure, where you are recovering the original structure which was break. Also for ionic liquids, even you have magnetic response, you have magnetic or carbon nanotubes or ionic liquids, where you apply a field, it changes behavior. So the smartness, it's the same, the definition is the same, although the look or the approach for application is a little bit different.
Yes, but for example, if you are taking the fluid, it will react just because you put some steel particle inside. And one of the materials used in the description that you are calling material will be because you have a external stimuli. It means the particle of steel will react with the magnetic field. If not, the fluid will not be smart, in fact. It means every time you have to compose something. It means you have to produce a composite. It cannot be a single material. I want to say it's not really in this way. Every time it will be a composite, it will be a combination of different materials will combine together, and one of these materials will react to an external effect, as for example, magnetic field, temperature, electric current.
So yes and no, because if we are talking about from our point of view, from chemical point of view, if we are thinking about molecule, it's a structure. It's not like one point. We have different parts of the molecules, and those parts react in different way. One of the part, and all of them are connected with each other, but one of the parts is responsive to magnetic field, the other part to the current, and the third part emit. It depending which force you will apply, you can have different behavior. So even if we are not talking about composites, although in actually application in most cases we are using composites, the smart materials can also, or smart behavior can exist in one single molecule.
Yes, but I was speaking just about the example described previously by the other speakers. I was listening also.
Yes.
Reported, and for me it was better to use, for example, some smart structures or something in this way, that smart materials, because it's really far from my description I'm using every day. But
but it's,
my opinion,
you want to hear that?
Yes, it's my field, in fact.
If I can just make a couple of comments.
Yes.
So Alexis, if you are looking at really a material, an individual material that has got various sort of capabilities, a material, an example could be a material like carbon nanotube or graphene. In this case, we have gone into this field and we have been excited about these materials because truly, these materials offer different capabilities. So for example, high thermal conductivity, high electrical, high strength, high surface area, high electron mobility. So, truly these materials could be sort of really classified as, as singular materials with these multifunctional capabilities, which we can then tune. But definitely most of the structures that we call smart would be smart structures. But if you look at the fuselage, for example, right now, this fuselage is just carrying the load. It's supposed to perform mechanical. It's supposed to be under certain mechanical performance. Now, the next fuselage that we are supposed to design, it's not just supposed to carry the load. It's supposed to store the electricity, and it's supposed to generate electricity. It's supposed to self-repair. So the same structure without changing, a kilogram of weight, supposed to do now the multifunctional capability, have these multifunctional capabilities.
Yes, I agree with you, but in this case, it's a group of materials. In fact, you are producing a structure will be available to do it. Sorry, because I'm not really using the same vocabulary as you, and my own definition, and you're using a smart material for some things that I'm using. For example, I will use smart material for shape memory alloy, but it is related to phase transition, for example. This was called a long time ago smart material, but when you are assembling some different kind of components, electronics, some materials, etc. For me, I cannot call it as smart material, but smart object or smart structures. But it's just a definition of, just a question of definition, as we are calling it. But I agree with you, of course.
I think it's important to align on terminology as well, because we have to make sure that engineers will work with scientists, with modelers, and also that definitely we are going in the right direction altogether.
Yeah, may I also add a comment?
Thank you. Yes.
Yeah, thanks. So I fully agree with Alexei that smart materials are by definition stimuli responsive materials. But what I want to emphasize that the stimulus, it can be very different. It can be mechanical stress, it can be light, it can be temperature, it can be electric field, it can be magnetic field, it can be something else. And for instance, you suggested that the example with the batteries, which I provided, can hardly be considered as example of smart materials, but we are really looking for stimuli responsive materials in batteries, because during the battery operation, we have expansion and contraction of the electrode material. So it's real mechanical stress, which results in the degradation of the electrode. What we need to introduce some smart material at the interface between the, let's say, grains of the redox active material to suppress this kind of degradation. So this material has to react to the mechanical stress, be responsive to mechanical stress, and responsive in the right way to keep the structure together, to prevent the degradation. The same for bio applications, which I mentioned. So the stimulus can be some chemical species which are, let's say, generated by living cells. Chemical species have to induce evolution of the material to provide, let's say, pathways for growing, I don't know, vascular system through the, let's say, printed tissue, and so on. So stimulus can be very different, but definitely smart materials have to be responsive. It's not just a composite which is smart because it has many functions. It has to be responsive to something. And stimulus can be very different. That's what I want.
Yes.
Thank you. Thank you very much. I have one question from the audience. And Ms. Szelwicka would like to ask about the present and future of carbon nanomaterials from the point of view, the implementation to the application in industry. So, maybe Professor Kozioł, he's working on carbon nanotubes a lot and carbon materials. What do you think? What is the, if you, okay, maybe other question, because it's all similar, but maybe more specific. What, in your opinion, is the future application of carbon nanomaterials? If you think about one goal where you would like to implement there, where would you go?
Przemek, that's not so simple, I'm afraid. There is not a, the one solution, because we have been trying to find this one magic use of graphene, for example, or carbon nanotubes. And it's not like this. I always describe these materials as engineering materials, and you have to think, what do you want to improve? And then think how to bring them on board and how to introduce them to structures. And just to answer Anna's question, there is massive amount of work that is happening at the moment, all over the place. I've been chairing a conference 3 weeks ago about turning these nanomaterials, with the graphene and carbon nanotubes into really commercial applications, and what are the examples? And I had about 100 people coming from industry showing actual real either prototypes or products on the market that already exist. So there are so many activities, starting from batteries. Batteries are one example where these nanomaterials are really, really useful. Improving composites, especially on electrical performance, rubber, for example, rubber composites. And people will come to me and say, nanotubes, graphene are still so expensive. But then I will say, you may pay $100 per kilo of these nanomaterials versus $1 for a kilo of carbon black, but you are using 100 only of these nanomaterials to make a difference. So actually, financially, economically, these materials, these expensive materials, as we look at them, are very already potentially, applicable for use. And I have a list of products where graphene, for example, is currently used, and you might have it in your pocket. right now, in fact. You might have it in your computer, because these are real products deployed and they are already making a big difference.
Thank you very much. And Gosia would like to say, comment something, or?
Yeah, I raised my hand because what you said just now really resonated with me, because I think this was the parallel situation to ionic liquids, where you know, you have a tool, you have a hammer, but actually this tool is multifunctional, like materials should be, and you have very different applications. So you can develop this type of materials in two ways. Either you are driven by fundamental curiosity. You know, can I make something that will have immense tensile strength? Or can I make an ionic liquid which will have series of properties? And that's good, because one day might come when this is very useful. But another approach is, firstly, don't consider, well, okay, now I have to make something that is biodegradable or very cheap, but ask yourself what it is you try to achieve. Because, for example, one very good application was given by Roland earlier on, but I was recently had very nice conversation about microsensors, and they also use ionic liquids, but you know, they use half a drop. And in this case, because they are able to have organic materials and they are able to reduce the amount of platinum and things like this they are using, I mean, truly, they do not care. And you have, it is attractive for a scientist, because you've got amazing playing field with molecules that you can use, because you need very little. And also biodegradability is not that important, because if you consider, we were actually talking about hydrogen sensors, you know, thinking of a future of a transport. If you consider this application, this is not the major challenge. On the other hand, I suppose when we come up with something really new, first time, it can be very expensive. It can be marveling at molecules, but we have seen that once you progress, there are always people who have more applied mind. They look at your idea, turn it around, and now we have ionic liquids. Well, actually, we are working with Professor Hrobok on ionic liquids that are cheaper as acetone or something like this. So it can be done, and that's how progress works, and it works in all directions. So we shouldn't say they are very expensive, it's a problem. We should just think what we need them for.
Yes, thank you very much. Our time is run out. So generally, I would like to thank you all the speakers. As you see, we approach this problem from smart materials from different point of view, from chemical engineering point of view, and I suppose that there are other views which I think we could discuss after. If you have any additional question or comments, you can always write to me or to respective speakers if you want to talk more about this topic. So I would like to thank you very much for the speakers, for the discussion, and for the audience to hear. And thank you very much.
Thank you.
Bye.
Thank you.
Thank you. Bye-bye.
Bye-bye. Thank you. Take care. Bye-bye.
Thank you very much for this discussion. I would like to thank for the session Smart Materials, Challenges and Opportunities, which was moderated by Professor Przemysław Data and participated by Professor Hrobok, Professor Bącel, Professor Trosin, Professor Małgorzata Swaćba-Kwaśny, Professor Rusinek, Professor Kozioł, and Dr. Kalb. And it's the time currently to invite you for the session Challenges Facing the Cities of the Future, which will be moderated by Professor Grzegorz Sierpiński. Professor Sierpiński is the coordinator of the priority area Smart Cities and Future Mobility. Professor Sierpiński, the floor is yours, and I wish you a fruitful discussion. Thank you so much.
Thank you very much, Mr. Rector. And now we will start the next discussion. Topic of the discussion is now challenges facing the cities of the future, and a few information about the panel. As our panelists include representatives of business, public administration, and science, I'm sure that the discussion will bring a broad view of the problem And let me introduce our panelists at start. Mr. Mariusz Stiba, Deputy Mayor of the Katowice City, Mr. Piotr Pustoszkin, Head of the Global Equipment Delivery, Bombardier Transportation ZWUS, is a part of Alstom Group, Mr. Mariusz Ntaflos, Mobility Analytics from Bentley Systems, Professor Magdalena Żmudzińska-Nowak, Deputy Head of Department of Theory, Design and History of Architecture, Professor Jan Kazimierczak, Dean of the Faculty of Organization and Management, and Dr. Marcin Grzegorz, Director of the Project Management Center at the Silesian University of Technology. And I will be the moderator of this conference. And before we start our discussion, let me give you a brief introduction to the topic. When the issue of urban development towards smart cities is taken up, there is usually a reference to the three distinct phases of the how cities embrace technology and development defined by Dr. Boyd Cohen. So in a big brief, Smart City 1.0 means the development of smart city caused by industry and companies that introduce modern solutions to cities. Smart City 2.0 is the phase in which city authorities make changes in various fields of their operation towards intelligent solutions and determine the direction of further activities. And finally, Smart City 3.0 is the time to make changes towards improving the quality of life and finalizing the smart city idea. And because of this structure, the first question I will address to representatives of industry and software companies. How do you think the development of future cities should be shaped, and how can the solution you propose help? Maybe representative of Bombardier Transportation, Mr. Pustoszkin first, please.
Yeah, thank you very much for the possibility to take part of this discussion. I will start, of course, maybe talking about this thinking about the current situation in Poland. We are observing that there is a lot of actions, effort regarding the new or modernization of existing railway lines between cities. The same we are seeing or hearing about the modernized airports, the central airport, and the new high-speed corridors. But for me, and probably not only for me, it seems that still when talking about the cities, especially the large and medium cities, there is no structured approach how to think about this so-called being smart, being the more, let's say, toward the people that like live there or living there, and how we develop and how we not only should, but how we are doing this development now. Because if talking about this, what is going on the agenda on the central level between cities, how we are spending the money, how we are taking this public grants to develop currently these lines, we are not observing such activities in the cities, to be honest. Yeah, we are thinking about let's say, some very limited solutions of the buses or the electric scooters, car sharing, and so on, but not necessarily about what new, what smart can we add to the city structure itself. So definitely electric buses, electric cars, when talking about the space on the streets, the congestion and everything will not solve the problem for a future. We need to think about some public transport, which is free from the clashes with the existing other form of transport or pedestrians. So it seems that the only way is a metro, heavy metro, something which costs a fortune, which takes the very long time to plan, to make it happen, to think about all the aspects. And it's very hard to afford by a single city or even the agglomeration of a city. So is there any other way currently? I think there are ways. There are ways, and the other cities are trying to use the, let's say, elevated, smart, not heavy solutions like light metro, light monorail, such constructions that gives the very big advantages. For example, we do not need to think about the, let's say, planning for acquiring the large amount of grant for such a development. When thinking about how to utilize the existing, for example, railway lines to make the bigger amount of people use it. It seems that the railway lines are quite often far from existing, let's say, the areas where the people are living, because let's say the way how the cities change their shapes is not necessarily was not necessarily followed by the change on a railway network. So we need to jump now. We do not have a grant inside the city for the new roads, for the new, to trace the new roads. We have no money to dig into grants to have a heavy metro. So it seems that such a smart solutions with elevated enough constructions that are preventing us from having the collision with existing modes of transport over buses, over trams, or even railways. Moreover, if we think that we don't know what will be in the future. We don't know how the cities will develop. If we'd like to trace the new route somewhere, the new, let's say, habitant centers or the high-tech centers or whatever, somewhere in suburbans currently, we don't know what will be the collisions, what roads we will put on the ground in the future. So using such solutions will prevent us to the high extent from such mistakes currently. And now we are also touching a little bit some aspects of not only technology, but also how touching the discussion. Shall we really invest in cities when we are observing depopulating, when we are observing the number of people in big cities are smaller and smaller? And this is not fully true, because we are also observing that in a quite number of cities, the number of inhabitants rise in Poland. So it means if a city could attract the young people that are thinking about the quality of life, the thinking about the not only the, let's say, very fundamental needs of having a work and being paid for, it opens the space for the development. Even if we talk about let's say the people in the cities are older and older, it's hard to really imagine that these older people will use the electric scooters or the other ways of, let's say, green transport, especially in winter. And if we combine such a bone transport systems with IT technologies that give us possibility to plan, to coordinate all the means of transport within the city, together with the buses, together with tram solutions, we could observe something more that is not that this bus and tram transport will be diminished by the metro or monorails. It's other way around. It will give us the chance to more use the capacity of existing transports that will steer the flow of passengers to the cities or to point of interchange of passengers. And such as solutions, I'm representing currently Alstom in our company exists. Thank you.
Thank you very much. Yes, the city space is limited, and Mr. Nataflos, representative of Bentley system, how do you think how will future technologies like exactly micromobility, e-scooters, etc., impact the future of our cities?
Hello, everyone from London. I'm very happy to be part of this discussion panel. I hope that everyone is safe. For me, the cities of the future will have a good mix of robust and reliable public transport services, micromobility, and active modes. I would like to see people living in cities with less cars and less taxis. I believe that micromobility is becoming more popular nowadays in our cities, although we know that the shares of micromobility are relatively small now. We expect them to rise over time. I think it's also getting momentum because it's very popular for accessing and egressing transit stations. And that's good because it will take over other traditional means like private vehicles and taxis. And I think we want this to happen in order to create a more sustainable urban environment. So imagine how less congested our roads would be if that was the case. I believe that the size and the speed of these vehicles make them well suited for urban environments. And I think that they offer flexibility and why not freedom to the users. However, I think that there are some challenges that we need to face and to overcome. Like, for example, the e-scooters, where should we place them? We know that the e-scooters are too fast to be placed in the sidewalks, but maybe also too slow to be used on the road. So it's very hard to define where the right place for them is. That's why I think we need simulation and transport models to be able to run as many scenarios as we can in order to each time change different parameters and maybe policies to see the impact on the transport network and ultimately on people's choices. I also mentioned active modes like cycling, and I believe that this is becoming popular nowadays in the cities. Many cities want to invest in cycling infrastructure and promote cycling. And I think this became very apparent to everyone during the COVID pandemic. I think many people wanted to cycle from point A to point B because that was relatively fast, but also safe, and because they wanted to avoid public transport modes in the fear of the COVID pandemic. So cities have built and are building cycling models to estimate cyclist routes, journey times, and flows for scheme and policy appraisal. And one very good example of this is the Cinnamon model here in London, which was developed using our software Cube. And the mayor and the local authorities 5 years ago, they realized the importance of investing in cycling, and they had to use a tool to be able to invest on that. So to conclude, I would say that micromobility and other technologies are very important for our cities. They will have a significant role to play for defining the cities of the future.
And that's why I think we need the right tools to do that. So yeah, thank you.
Thank you very much for this answer. And if we started with definition of challenges from the side of the industry, now I would like to ask the question to the Deputy Mayor of Katowice City. How does the Katowice city define future challenges related to quality of life, for example, and how do you think, is it possible to standardize the development of cities across larger area like metropolitan area? By standardizing, I mean the definition and implementation of a common direction of development. Mr. Skiba.
I assume that we are all in the same time zone, so good afternoon to everyone. Hello. I would like firstly to thank for invitation on behalf of Mr. Mayor Marcin Krupa for invitation to this panel and for possibility to sharing of the ideas and the challenges which our cities, the self-government in Poland has. While thinking about the challenges of the city of Katowice, I can't start without mentioning the most important document, which in Katowice is the Local Development Strategy 2030. It's the most important document of long-term planning. It sets out a framework for development and planning for investments and non-investment activities in all aspects of urban development. The strategy formulates 4 strategic areas, which are as follows: the quality of life, which was mentioned somehow, and it was mentioned also in the question I was given just before. The next very important area which is pointed in this document is metropolitan nature and the city center. The another one is entrepreneurship and economic growth. And at least, but not the last one, is the transport and the city logistics. The first one involves our attention the most regarding the fact that Katowice is the main city of metropolis, which is the place to live, work, and to rest. Remembering the fact the city is, first of all, for its citizens, we are facing many challenges, but I would like to mention one of the most important. Getting the most popular in last years is the issue of city resilience, which got bigger importance during the pandemic situation recently. The main challenge to all of the cities seems to be building the city which is resilient, especially in social and economic aspects. I have to highlight that it doesn't only mean dealing with the effects of the pandemic, but first of all, preparing the cities to stay immune to the future shocks and threats. Another very important issue, the challenge we actually cope with since our transformation, I mean the political transformation, not just the transformation of industry, which the city of Katowice has been undergoing recently, is the demography. It's still our challenge. Unfortunately, we are facing still diminishing number of citizens. Although the city has introduced numerous initiatives to attract new residents. Another issue which we have to consider, which we have to take under consideration, is the change in the issue of aging society. In this issue, we need to take advantage that being aware of the fact that the share of seniors in our society is increasing, we have decided to build the policy on seniors, which includes programming and operational aspects, including infrastructure and services dedicated to seniors. A very important issue in terms of our national policy, not only the issue of self-government, but it is very important in the issue of the rank in which many Polish cities suffer because of this problem. Is the problem is the challenge of air quality, in which we have some experiences from the last year, but we've got a lot to do in the closest future. Our activities in this field refer to short and long-term initiatives. Those refer to educational and investments aspects, which for us are equally important. Considering the implementation projects aimed at improving air quality, Katowice is the leader in the Silesian Voivodeship. We also run a numerous projects of complex thermomodernization of housing and educational buildings using EU funds, and we are in preparation of other sets of buildings to be modernized with the new project of the clean air. What is more, we are also the beneficiary of the European Commission Horizon 2020. In December of last year, the city, our city received means for the project Upsearch, which is actually focused on improving air quality by using nature-based solutions. What is from our point of view bound with this issue is the challenge of climate change. In this issue, in this field, we've got another document, which is a climate adaptation plan by 2030, which was adopted by our city council 2 years ago. The plan indicates the vision, main goals, specific objectives of the city's adaptation to climate change, which should be achieved through the implementation of selected actions in 4 most sensitive areas of the city: the public health, undeveloped areas, transport, and water management. It provides many also, including green infrastructure. Although the city is one of the greenest, our ambition is to introduce more green public space also to the city center. Here I would like to mention that the project of, for example, Warszawska Street, which is gonna be much more greener than it is now. And the project is estimated at about around 3 million euros. And much more regarding to those words which was just said by the guests who focus on the issue of transport, intelligent transport system, which somehow this is directed to the institution of Metropolis, which was provoked in the question. The city of Katowice has taken a number of action and gained EU funds for the implementation of a transport solution, and that those regards the construction of the system of transport hubs. During last months, we have just opened some interchanges system, the modernization of trams and buses infrastructure, intelligent traffic management system, which is supposed to give the priority to the public transport vehicles. And because of the fact that the city is the heart of metropolis, it is the place to live, work, and rest, we decided to build the interchanges in the vicinity of tram loops, which improves commuting to the city center using alternative means of transport than private cars. It will definitely reduce the travel cost and also the time. Further changes in the area of intelligent transportation as the changes in parking policy concerning the central zone in Katowice, and in upcoming session of City Council, we will deal with the adoption of rules which will change the fees, which will change the level of payments for the parking. Another point in this field is further development of electromobility. The city of Katowice is the first one in Poland which complies with the electromobility laws by installing 58 charging stations with 124 points that have been launched in the city. And in addition, charging infrastructure for public transport was built, which is currently used by 10 electric buses. In Katowice, we started working on the development of electromobility actually 9 years ago. And looking at the global development of this area, we hope that 8 years it will become our daily routine, especially since electromobility is one of the methods of combating air pollution and noise.
Thank you, Mr. Mer, for this opinion. And we see there are a lot of challenges defined for the cities from the public administration point of view, and maybe to achieve the cohesion on the part of industry and public administration, it is the way to determine the second phase of the smart city. So we will skip to the next point and to the scientists now. How do scientists view the problem of the challenges facing the cities of the future? Maybe Professor Żmudzińska-Nowak, could you start tell us about it?
Thank you very much. Thank you for invitation. The problem is very interesting. So I realize one can ask the question, what is the relationship between smart cities and mobilities of future and the cultural heritage, if even is, because I would like to talk something about the cultural heritage.
Yes,
as a challenge for the smart city. So I would like to start from defining the notion of smart city. In my opinion, the idea of smart city is containing at least two aspects. The first is modern development based on advanced technology and innovations. The second aspect is a human capital, means social activities and engagement. And the definition is very close to the Smart City 3.0 that Professor Sierpiński just mentioned. Both aspects that I mentioned above, so the modern development and the human capital, must be deeply rooted in tradition, identity of place, and different forms of continuation. Simply, smart city should be rooted in cultural heritage values. Heritage is much more than building and sites. It is a permanent process of inheritance, acceptance, and care. I would like to emphasize that the heritage is the essence of and the foundation of the city, particularly smart city. And the question is how we could manage with this challenge of heritage nowadays. If possible, I would like to just to illustrate the problem and this integrated approach. I would like to refer to my personal experience, professional experience, methods and project conducted by my research team at the Faculty of Architecture. Every time we undertake projects that are focused on historical buildings, sites, urban layouts, and post-industrial structures and facilities as well. They are very typical for the Silesian region. And our approach is dedicated to heritage. It always combines 3 steps. The first step is conservation research, buildings examination, values assessment, supported by use of advanced digital diagnostic techniques as digital data, digital tools, and data obtained from this research is the way to implement them to BIM and HBIM models. And it is the first step. The second step is the preparing projects of conservation, modernization, and adaptive reuse. Because adaptive reuse in very modern way is a very good solution for the historical buildings, also in smart city. But the third step, in my opinion, the last but not least, is the popularization and widespread education in order to extend the common knowledge of heritage values and the social awareness about the heritage. So these 3 steps is very crucial for the process of conservation and of taking care of cultural heritage. One of the basic conditions of elaborating of this kind of project is a constant cooperation with the partners, which are stakeholders of the project. Thanks to them, we can solve real problems and implement solutions in practice. Thanks to this model cooperation, our research and knowledge is transforming to useful knowledge. Not only just we are trying not to conduct just research and project, but to be useful for the surroundings as authorities and partners, social partners. How to summarize these short characteristics? I would like to say that the city is much more than buildings and sites. City is one of the crucial elements that linking people and cities, linking memory of the past and vision of the future. To summarize, I would like to emphasize that it is only approach to create cities real smart. So thank you very much.
Thank you very much. How can science help transform cities into smart cities? Professor Kaźmierczak, please.
Thank you, Professor Hepiński, for giving me the floor. It's not easy to say something meaningful after my honorary first speakers, but I will try to do my best. So let me start with the trivial statement. Of course, the problem of creating the smartness of the city is of high, or even the highest importance of the contemporary time. But I would like to ask a simple question. Why the city should be more and more intelligent? Okay. I think not because of the expectations and needs of providers of technologies. Never mind technologies of IT, technologies of transportation, and so on. Not because of expectation and needs of local authorities. The city should be more and more smart because of the needs and expectations of inhabitants. But of course, we have also to state that something like an average habitant doesn't exist. We have, it was mentioned by Mr. Skiba, we have a variety of people living in the city area. Once, we have to consider the group of, let's say, the educational age, the work active age, and finally seniors. Of course, I do agree with Professor Żmudzińska, we have to consider also the presence of tradition, not only the heritage understood as the in your presentation, but also the habits, the local tradition, perhaps even the tradition of very small societies living in the particular places. At the moment, if you try to look at the publications concerning the problem of intelligent areas in the urban areas, you can say that almost all the cities in the world are intelligent. But I'm afraid that if we will try to ask inhabitants in the city of, I don't know, let's say Gdańsk, are they living in the smart city and why the city is smart? I think the answer should be not so evident. Finally, I would like also to mention the problems which are not necessarily of technological nature. For instance, we can certainly lead to increasing the density of technologies in the area of city. But we have also to consider some elements of the behavior of inhabitants. For instance, the phenomena like technophobia. Perhaps some of inhabitants could be really afraid of living in the area which is so heavy densized by the new technologies. So answering directly your question, Professor Sierpiński, to me, what we have to do is to cooperate for the future. The cooperation is necessary between the providers of technologies, between the authorities. Thank you, Mr. Skiba. Your presentation was really interesting and was showing that the authorities of the city of Katowice are really afraid about citizens, and I thinking in a good way about the future of the city. But I think the third actor of this set of stakeholders, I mean the scientists, have also to be deeply involved in the future works, both the scientists who are concerned with the purely technological things, but also the scientists who can support technologists by considering the problem of, let's say, the social and also economical nature. May I end with a joke? We are talking about the smart city. To me, it's something like the discussion about the Nessie of the North Loch Ness Lake. Everybody is talking about, nobody has seen it. So it's a final part of my presentation. Thank you for giving me the floor.
Thank you, Professor. And when we are talking about technology, very shortly, Dr. Górski is one example of technology you could indicate, which in your opinion will be more and more important in the near future.
Thank you, Professor Sierpiński, for giving me the floor. I'm in even worse situation than Professor Kazmierczak, having heard what my distinguished predecessors have said. But well, I will also try my best. Well, I will try to say something not only from the perspective of somebody connected with the project at our university and having some insight on the programming of European Commission in terms of Horizon 2020, Made in Europe, for example, where the smart city appears many, many times in many aspects. but also as a civil engineer, practicing civil engineer and scientist in this field, who's also trying to think about all of the elements mentioned here before. So one, of course, very important issue is that not everybody is happy about technologies. That's true. And there's supposed to be zones in the city that they are free out of technology, however, providing some safety. But these zones should be most probably surrounded or accessed by something that is supported by technology, and something that unifies and collects all of the elements that has been already mentioned here. So municipal problems, historical heritage, social issues, transportation is the infrastructure. I mean, existing infrastructure in terms of historical buildings, in terms of road infrastructure, existing buildings, and the infrastructure that is already planned or is being constructed. So this should be, of course, safe. This should be well maintained, and that should be, in my opinion, smart. And
Thank
everything.
You. Thank you, Doctor. If I may stop now, I'm sorry for this. Time passes very quickly.
Sure.
We just start the discussion, but we have to finish now. I hope it will be next occasion to tell more about these solutions and the visions of the future cities. And I would like to thank you all the panelists for the very interesting discussion and comments. And I think it has helped us to provide the main goal of the panel, defining the challenges facing, defining the challenges facing cities in the near future. How next occasion to discuss, and thank you very much for this for the audience, and thank you the panelists one more time. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.
Everyone. Thank you.
Thank you very much, Professor Sierpiński, for organizing the panel, Challenges Facing the Cities of the Future. And I would like to also kindly thank the Deputy Mayor of the Katowice City, Dr. Mariusz Skiba, Dr. Putoszkin, Mr. Taflos, Professor Kaźmierczak, and Dr. Marcin Górski. Thank you one more time. And now I'd like to kindly invite you to the next panel discussion, which is Industry 4.0, Society 5.0. The panel is going to be moderated by Professor Anna Timofiejczuk, who is the coordinator of the Priority Research Area 5, Process Automation and Industry 4.0. Professor Anna Timofiejczuk is also the Dean of the Faculty of Mechanical Engineering. Please introduce the panelists, and I wish you successful and fruitful discussion. Thank you so much. You're welcome.
Thank you. Thank you very much. Welcome to everybody. Maybe at the very beginning, a few words about our priority research area. So we are divided into 12 topics. They are listed currently now in the slide, in the screen. And you can see that we are a very broad group of people in means of our scientific interests. So we are engineers, but what is very, very positive, in our group, there are also people with humanistic backgrounds. So we have also philosophers, sociologists, and also psychologists in our group. I welcome you to visit our webpage, which is currently new. And we try to put there a lot of fresh information. It is very easy because it is PolSL, like our university, and the number of our priority research area is number 4. We are here. All research areas are in the first page. of our university. I have a great honor and thank you very much that these people, which are listed currently in the screen, they accepted my invitation to the panel. So let me briefly introduce themselves. It is Professor Hasan Haraf from Budapest. He's currently Dean of the Faculty of Electrical Engineering and Informatics at Budapest University of Technology and Economics. Hello, Hasan. Are you with us?
Hi. Good afternoon for everybody. Thank you, Anna, for joining you.
During our discussion, you will have opportunity to learn Professor Hasan Haraf a little bit more. But for me, when I could say something very briefly, it is like a dean of a type of deans of dreams come true. So everything is possible for him. And his very well-equipped laboratories, very motivated students, and so on. Then we have with us Artur Polak. Hello, Artur. Are you with us?
Yes, I have to unmute my microphone. Hello.
He's a president of one of the leading companies in terms of Industry 4.0 in Poland. And he's also his company, and he personally, he's distinguished with the very prestigious distinction in terms of industry in Poland. It is signed Now Poland. Thank you very much for accepting my invitation. Then we have Dominik Rormus, Dr. Dominik Rormus with us. Hello, Dominik. Are you there?
Hello. Yes.
Thank you very much. We have also a very small surprise from his side because there is something fresh, new ideas. I'm talking about your 2 slides. He will present it in a few minutes for us, but I have to say that I learned Dominik Rormus in Warsaw. It was a seminar organized by Polish-German Chamber of Commerce, and he is one of people in Germany who simply established Industry 4.0, and he's responsible for a lot of regulations. Then we have with us Andrzej Soldaty. He's very, very recognizable person in Poland. He's the first person who comes into mind when we think about Industry 4.0. Hello, Andrzej, are you with us? I saw that Andrzej is in the list, so probably he will join us in a few minutes. Maybe there are some problems. But I have to say that it is a person who is responsible for Polish Industry 4.0. My name is Anna Timofiejczuk, and currently I'm coordinator of the priority research area. I'm the coordinator, so it means that I try to gather all achievements and all people at our university who work in this area. And it is really very, very huge group of people. Well, the goal of this discussion panel, the purpose is to answer to some questions. I wanted to ask you about some, maybe not specifically about these questions, but something around what is now visible in the screen. What does it mean, Industry 4.0 for you? What is Society 5.0? Are we Society R0? Should we afraid? What we should do to our students, how we should cooperate. And because the panel is at the Technical University, Research University in Poland, I wanted to end with some recommendations to the research society, to the industrial partners, and also to organization from our environment. So let me start from the very beginning. It is for me very interesting. For example, when you think about the moment, you, for the first time in your life, you heard Industry 4.0. Do you remember this moment, that moment? And what was your opinion? I remember it was 2016, and I was exactly at the same place as today. I think it was the same chair. And opposite to me, they were two people from the industry. One was well known to me because it was my old friend from the industry. And the second one was very weird people. It was Andrzej Soldaty who told me for the first time Industry 4.0. And to be honest, I thought, well, what is new in this slogan? What is, we have everything. We have laboratories devoted to these technologies. And well, I thought that because he has very big enthusiasms and he suggested me to develop this idea at our university. At first, I thought that he's a little bit crazy. It was 6 years ago, but for me, it was like ages ago. We did a lot together. He, meanwhile, became my best friend 4.0. And yeah, thank you very much, Andrzej. I hope you hear me. But Andrzej, are you with us? No? I don't know. Please check whether he's in the list. Mm-hmm. If not, Artur, could you tell us when for the first time you heard the slogan Industry 4.0 and what was your opinion?
Thank you for giving me the floor. At this moment, I think one of the biggest enthusiasts of Industry 4.0. So I don't really remember the situation when it happened, but I think that I live in Industry 4.0 since I finished my faculty. And the first time I think that I have heard on one of the conferences organized somewhere in Poland, and also during our projects we did by our customers. I know that somebody came from the conference and said that there is a new idea about this Industry 4.0, and I was very surprised. I asked him about some details, and he told me about the connectivity, about the using the data for predictive and such things. So I was really surprised that such a things we consider this time, because I was one of the person who was taught by Professor Antoni Niederliński, and about 30 years ago he described all the future. So this time when we live here at this moment, he described this 30 years ago. So because of this, I say that I live in Industry 4.0 since 30 years. But the idea was described about 2014, I think for me, like a definition or like a slogan. And since these days, we start to develop our platform for industrial Internet of Things. So this was my idea for the company I lead. And since these days, we discover this word, and we also give the information to our partners, our customers, that they should go this path, because there is a gold on the end of this. Yes, this data is gold of our time, and we bring this information to everybody who would like to hear something about this. We show the exposition. In 2017, we took a part in Hanover Fairs, Hanover Messe, how we call this in German language. So we show our platform in 2017. So our response for this idea from 2011, in 6 years, we had the ready platform to show that our Polish way of thinking could answer this request from the market. Of course, when I compare the situation about Industry 4.0, I started to work with industry in 1998. So my first project was in Skoda factory. After this, I worked for Daimler. And 2001, I had the pleasure to make commissioning of the factory where there was no human beings and there was 450 robots. So this Industry 4.0 exists nearly from ancient time for me, yes. And now we name it Industry 4.0. But I think that this is a very good job and this is a very good activity. And this is what Silesian University is doing. It's a really great job because we have to bring a lot of new people, new students who will enjoy this idea and will follow this path. So I'm really excited since a couple of years, but there was no detailed point.
Moment.
Yes.
So thank you very much. So the second name of Artur is Industry 4.0 simply. Andrzej, I see that you are with us. Andrzej, do you hear us?
Yes, I can hear. And
okay. There were some problems probably. Do you remember the moment you for the first time heard the slogan Industry 4.0?
I can say that I was from the beginning with this concept because this time when this slogan was coined in Germany, I was working for a German company, Festo. Festo is one of the leader of Industry 4.0, and I was directly involved in projects which were relevant to this concept. So I can say that from the beginning I was acquainted with this idea, and I was trying to move the concept to Poland by, for example, organizing a special presentation by guests from Festo headquarters. One of such event was Festo Poland anniversary, celebration of anniversary, and I organized a big presentation of the concept of Industry 4.0 in Poland. So it was something quite new, quite fresh, and not recognize value on the Polish market. What does it mean? But I can say for me it was something like next step in my technological development in Festo. It is something like a normal way of development.
Thank you very much. We moved into Germany. Dominik, you are very, very experienced, and you are one of the, I would say, the main people in Germany in terms of Industry 4.0. Could you tell us about the beginnings? I saw your presentation. It's very impressive.
Thank you so much, Anna. I would like to follow also Artur, what he just said. And to be honest, not too long look back, but rather look to the future and point ourselves to the future on what is coming up. I was first with Industry 4.0 in 2009 and 2010. Then there was the term initiated exactly 10 years ago at Hannover Fair. Today we have the last day of the Digital Hannover Fair 2021. So, and then in those days it developed. The perspectives were different at the beginning. Now we have basically three dimensions that we are looking at. And please allow me, Anna, that I don't go into first, second, and third here, but the dimensions are really that three elements need to come together. One is interoperability. That means cross-vendor interoperability. The second is sovereignty and autonomy. And the third is sustainability. And just let me elaborate on sustainability a little bit. That's not just climate change and all impact coming from that. That is also how do we work in the future of a completely networked and fully with artificial intelligence solution and technology supported work environment. And that covers all. It's not just about factory or shop floor. It covers all elements of the value networks that we can even think of. And this transition comes in phases, and there are certain developments more in one direction, one in the other. When are we ready with Industry 4.0 would be a question I would love to answer, when those three are available at little cost. I'm an industry guy, and And in the end, we have to bring that also to cost and value. So we have to have value add. Each individual technology itself is not a value add. Only the combination of all is then really the value add. And that brings us to these new developments that we see in Europe. They call it data space. I'm not sure if that's the perfect word, but I would like to at least note this term. It's more initiate and enable new businesses based on a digital economy and digital ecosystem that we are not used from the past. And you in Silesian University and you personally, Anna, and you might remember our discussions. By the way, it was in Warsaw in October, middle of October 2019. To be honest, it feels a million years ago, considering the pandemic situation since last year. And that was shortly before, to be honest. So these data economy-based principles operate and work differently. In the future, there will be no more value chains. This will be really in value networks. And I'm more than happy to elaborate on that in the minutes to come. Thanks. Back to you, Anna.
Thank you very much. You answered to my future questions simply, but I will ask you once more about some issues, because I wanted to, my favorite topic in discussions with Andrzej currently is differences between transitions and transformation. And I would like to ask you about these differences. And Hassan, you are Dean of one of the best faculties in Hungary, for me in Europe even, in terms of automation and robotics. I saw your laboratories. And even more, I don't know whether you know, but at the Budapest Technical and Economics University, there is one of very well-equipped and well-organized Center of Competences of Industry 4.0. Could you tell us how it was established, what was the background, and how your faculty, your students cooperate with this center?
Thank you, Anna, again for the invitation, and it's my pleasure to join you on Friday afternoon. A couple of words about your previous question about the start point of Industry 4.0. For me, I first heard about Industry 4.0 from colleagues from Fraunhofer Institutes from Germany here in Budapest in 2014 in September. And of course, we have cooperation with Fraunhofer Institutes, and from that point, for me, it's a new wave of technologies. We can use this new wave to make our companies, our solutions more competitive. But Industry 4.0, for me, can be summarized with 3 words. The first one is integration. Integration between the physical and the virtual world. And this means it's the consequence of this integration. It means it's a big or a full control of the full product chain. And the third word or third expression is a data-intensive, solution-based thinking way. And what does it mean for us? It means that here we have a question. Are we different from before Industry 4.0? Yes, we are totally different because our solutions are different. Our solutions are based on data. Our solutions can be automatized fully. And of course, the integration can happen vertically and horizontally inside and across the companies. So that's why for me, Industry 4.0 is not only a buzzword. It's a real evolution step in our technological world. And we are here now. And of course, we can transform these solutions to other fields also, not only for manufacturing. And here in Hungary, 4 years ago, we created a platform for companies to join in one place. It's a cluster of companies, SMEs and multinational companies together, and of course, academic institutes. and we created the Industry 4.0 platform. I made a presentation about that in your university 3 years ago. And the idea was we have 1 day a year, when we have open day during the night and the day for people in Hungary to visit the manufacturing places. And now it's virtual now, unfortunately, because of the pandemic. But typically we have this special, let's say, smart factory day, and you can visit any factory here in Hungary. And the Hungarian government allocated a budget for this solution to make Industry 4.0 solutions and to motivate the factories to move one step forward. And of course, the Hungarian SMEs to join this chain. And a part of this budget, we had an idea here inside the university to create a knowledge center about Industry 4.0. And as I showed you here in Budapest, and it's a showroom for Industry 4.0 solutions. And the idea behind is to make a gateway for the companies here to join us and to come to the university to see and to touch these solutions in an open way in 250 square meter areas. And of course, the scenarios developed here inside the departments can be shown to the companies. And it doesn't mean, let's go buy a Siemens solution or an SAP solution. No, for Hungarian SMEs, it's a cheap solution, small solutions for different parts of an Industry 4.0 system. And from that point, we had a lot of diploma work made inside this center. And now I think since you visited us, we have 2-3 new scenarios showed also here inside this laboratory. So it's an idea to make a bridge between the Hungarian small SMEs and the university, because before that, the R&D projects happened between big companies and the university. The small companies are outside this game. So I think this is a motivation also for the government to support these activities here inside the university to make, let's say, a gate for the small companies to join and to see these solutions here.
Thank you very much. I wanted you, all our audience, to hear about this example, because for me, it's a perfect example. I saw it, and there are places for living labs, case studies, and so on, which is prepared by university people and by students. We agree that we did last 10 years, even maybe shorter time, a lot in terms of Industry 4.0, but there are still new ideas. And one of such ideas is Gaia X. Please, Dominic, tell us something more about it.
Thank you very much. Yeah, possibly you just moved to the second slide. Even didn't put a title there, sorry for that. I would like to catch up on several things that just Hassan mentioned, but also before Arthur and also André Soldati. It all fits perfectly together. Let me just elaborate on what Hassan said. He is creating an ecosystem around his university where you have a playground. He didn't tell anything else than he creates a neutral, accessible playground to try out not only technology that comes for free, more or less, these days. That is different 10 years ago. So if you ask me for a difference 10 years ago, Industry 4.0 and today, there's really a difference in technology availability and technology maturity that we have to admit. Yeah. These days, IT technology is available for free, and it's not the topic anymore. It's the topic on how we, in a business-to-business and research-to-business environment, can make value or can create value, can make money with that. In the consumer area, all the players, Amazon, Tesla, etc., showed it to us. But for business to business, it's extremely different. And it shouldn't be underestimated that it is different. It is not a one-to-one copy. It is not. So we initiated in 2018 together with France, Gaia-X. And this is exactly the ecosystem that Hassan just talked about when he said he has a local Hungarian repository, put it this way, please excuse the term, kind of a repository where he solves his interoperability problems. So when Hassan moves with his Hungarian small, medium enterprises, and not only the big players in Hungary, he needs interoperability solutions, interoperability technologies. I'm pretty sure he's aware of the asset administration shell, which is full-scale semantic information modeling across not only from machine to machine, but across all, let's say, parts of a factory, human resources, payment, financials, contracting, scheduling, engineering. He is talking about the realization of Industry 4.0, which we call the digital twin for Industry 4.0, which in technical term we call asset administration shell. It's not a good word, but don't care about words. So if we bring that in, then we see an X. So we see a top layer in blue, a green layer in the center, and then a red layer on the bottom. That's the X of Gaia-X. The term Gaia was introduced by a guy. It's a Greek thing, forget about that. It's only about the X. And what is important? It is important that sovereign data exchange among and across all industries and sectors is possible. In this blue thing, there's agriculture, there's industry, there's healthcare, there's public municipal services, there is maritime, etc., transport, automotive. All those have data spaces, as we call it at the moment. Why should I, in a business-to-business relation, be willing to share data? I would always say, no, I don't share data. You know it, you can list it all and you know it all. That comes in this green thing. In the green thing, there are topics like IT security in the center of that X, IT security problems. How can I ensure IP protection if I, as a small, medium enterprise in Hungary, share data with a small, medium enterprise in Poland to create a new business model and offer that on a European scale immediately? And you even don't know your customers forefront. Those might be customers in Portugal or Estonia that you even never heard of, because your network, even if you have 1,000 people in your network, will never reach to the last village in Portugal. No way, even not with the classical European funding schemes that we are used to since minimum 40 years. And we are very, very much aware of those. How can you reach out to those and create things? You need trust. Trust is the key to success. You need technical trust. Trust in a technology way, beside interoperability. This is really in this green bar. You need compliance for that. You don't want to reinvent the wheel. So you need standards and norms and regulatory on a European level based on European values. And those values are identical in Poland, Hungary, Slovakia, as in Germany, France, Spain, Netherlands, Sweden, and whatever you want to add. And those things need to be worked out. So Gaia-X is not a pool of servers. It can be provided by Amazon Web Service, Alibaba. And that brings me exactly to the point. So Hungary is exporting to the US. Poland is exporting to the US. But in the same way, and at the same moment also to China, India, Korea, Japan, and others. And if you do that, at the moment, these Hungarian and Polish companies have to develop it 2 or 3 times. Those are proprietary cloud systems. And you cannot use an Amazon Web Service app and port it to an Alibaba platform. It's impossible. So you have to develop it 2 times. When you have Gaia-X as a standardization setting organization, you develop it once. And if you get Gaia-X services, which will be certified by agencies, so Gaia-X AISBL, the Gaia-X headquarter in Brussels, will take care of that. They will not do the micromanagement. They will take care that Gaia-X and the label Gaia-X can be certified. Then all of a sudden you are compliant with Chinese Cloud Act or US Cloud Act. If China or US does not allow a certain level in that green thing with respect to compliance, then we will notify you on that there's full transparency, full transparency. So there might be limitations due to local regulations in Asia or in America when we are outside European Union. But then you get part of that label and it is transparent on what you can reach out and what not. And based on that, you can, and that's the red part at the bottom, rely on technology that, and this is the free market, software, hardware, whatever you want to offer. And this can be certified. And yeah, you need to know one last thing. Data is copyright. So the legal aspect of data is copyright. It's less IP. And that copyright law is around the globe differently. We have about 195 different copyright laws according to members of the United Nations. So you see it's quite complex. It's a huge endeavor of Europe. I'm super happy. If you not would do it, then only two big mega players with lock-in effect will survive. I just named them. So why not trying in Europe? We have Hassan, we have Arthur, we have all those Brad, we have you, Anna, you have all these bright brains. So we'll do it. So we'll try it and we'll do it. And Gaia X started in March, and I'm more than happy to have Hungarian and Polish Gaia X hub. Thank you very much.
Thank you very much, Dominic. I wanted to turn to Arthur, in fact, because he represents a company who works in this area, but we aimed, in fact, the title of our discussion panel is Industry 4.0 and Society 5.0. We agreed that we are different. We are different than 10 years ago, than 5 years ago. We simply operate. We use different devices, and it is very comfortable. But in some ways, we feel sometimes insecure. We fear. Arthur, please tell us, maybe before you answer to my question, just a very short explanation. Society 5.0 is a slogan, is a term which was created in Japan. In Japan in 2016, so it is quite fresh idea. And in Japan, they realized that we people, we are different. There is a lot of data, a lot of software, and there are no regulations, governments and politics. It is behind of them. It is impossible to regulate and to control everything. And simply because of that fact, we are different. Arthur, please tell us, because in your company, you create products which help us to move to the society 5.0. Are we people 5.0, or we are just becoming such people?
This is not there is no easy answer, I think, because generally Industry 4.0 is a very complex idea, and society 5.0 is much more. Because we, like human beings, we all understand the technology, and this what new times brings to us in different way. A lot of people, they are thinking that this usage of the technology, this is a smartphone technology, and sometimes they are right. And we, like engineers, we have to create the whole background that they are safe, they can feel safety. That they can trust the technology, and there is no digital exclusion. This is very important for us. I would say that at this moment we are expecting to be the society 5.0 because, like you show on this drawing, there is a lot of electromobility, self-driving cars. Exchange of the information, AI behind big data analytics. Normally, I would say that we are living in a bulb, because even this conference we are discussing about the very complex philosophy. And when you go outside of this conference and you go to the street, nobody would understand what we are talking about. So I would not say that society is not clever enough to understand, but they are focused on quite different ideas. They are focused on working, living, spending the time, and this is normal human being. And we have to develop the solutions for the market as safety as this is possible, and to bring solution for all the odds, because there is a lot of people who don't use the technology, a lot of people who cannot live their full life. So this technology brings us in social networks. This is very important, and we are the company who solved the problems, I would say, since 20 years. On the beginning, we were the company who deliver some solutions, but after 20 years, I would say that all the time our customers call us because they have problem and could you help us? So we are helping company. APA is like an APAP, yes, we paracetamol, yes, for some ideas. And we also developed this technology to bring this alive, that people can use it, can understand this. So we are working together with psychologists that we understand human beings, their demands. We are like a human beings, we are not constant. Because today we are thinking on right side, and next days we will go left, for example. So we change our minds every time. And I think that technology will show us the way how to go forward. And we, like a society, we can use this technology in smart way. We like technology. Generally, everybody like Netflix, internet, social networks to exchange our minds. And this is very good. And in the background, we try to bring this solution to industry. At this moment, I am working together with over 20 persons who are experts that we try to bring solution to small and medium-sized enterprises, how they have to bring this change to their companies. But in companies, they are working people. So human-centric idea is the most important for me, because if you will bring technology and the people inside, they are not convinced that this technology is good for them, they will kill the technology. Let's say like this. They will not copy and paste. And because of this, we have at this moment a lot of platforms, a lot of ideas. And personally, I'm against these numbers, because at this moment we are talking industry 4.0, society 5.0. Nobody understands this. I think that we have to be modern and open-minded to bring the solutions. These solutions, they are just tools to make us better for living, for spending the time. So this is very important, that we are fighting against the problems we have in the environment. We have to take care about the earth. We have to take care about animals, about all the people. They have no access to the technology, because we know that people in Africa, in other continents, that they have another level of the problem. So we are living in the bulb. We are very clever. We use data science for predictive the future. So we can make our society better. We are going in this direction 5.0, but we have to be also clever, because we would like to be in a safety chain. We don't want to have chains. So this is my answer. I have visited Japan because I was looking for the technology, and this is what I have seen there. They use their habits and they bring this technology. They use their minds, and the technology is in the background, I think. So
thank you very much, Artur.
Excuse me for this long.
No, it was very nice what you said, but I wanted to say that I carefully selected these two pictures. This color one shows that currently we are trying to remove the right position to the human being. So we are in the center, in the industry 4.0. And because of that fact, people like Hassan, create and develop like our university. You mentioned also that we created this software together with our university. Yeah, so it's very nice. I wanted Andrzej Soldati to summarize our panel. Could you say a few words? How do you see, because currently, I think maybe it is not a secret, we are creating something new together with Andrzej at our university. So could you tell us a few words, how do you see the future cooperation between companies like Andrzej, like universities, like Artur, like universities, like organization represented by Dominic? Andrzej, please.
Thank you very much. I can say so. First of all, when we are talking about new industry, new generation of industry, new generation of society, we should analyze what was the background of these changes. And of course, in the case of industry, we are talking about forces which are coming from outside. It is behavior of customers. It is a new landscape of competitiveness. It is also changes in resources. It is social changes like aging of a society. And when we are talking about Society 5.0, I can say that it is a background of limit, because there is a limit to what people can do. It is typical in the history of mankind. A key factor of social changes has been to achieve a limit of the effectiveness of the existing way of functioning. It means hunting and gathering society, growing population, and not stable resources required changes in direction of control resources. Agricultural society, achieving limit in potential to process natural resources by handwork. Industry society, achieving limitation in creating value in physical interactions. Information society, achieving limit of getting and changing information with human involvement. And Society 5.0, it is sharing information by connecting with IoT, implementation artificial intelligence, and of course increase human potential in mental area and also in physical area. It is something like summarizing what we were talking about. It means orientation on human. And a question about future. Of course, typical for Society 5.0 is integration. Typical for Industry 4.0 and Industry for Future is integration. Integration, it means connectivity plus trust, and together create a new network of creating value. And absolutely it's clear that when we are talking about future, this integration and networking, it is key for success. So it is something like my motto for the future.
Okay, so yeah, thank you very much. It is perfectly said. What I add at the very end, I have to say that another name for Society 5.0 is Society of Creativity, Society for Imagination. And I hope that from our panel you understood that we are just becoming such society, or we are just this society of creativity. Thank you very much.
Thank you very much for this discussion on the topic Industry 4.0, Society 5.0. Thank you very much, Professor Anna Timofiejczuk, the coordinator of Priority Research Area Process Automation in Industry 4.0, and thank you to the panelists, Dr. Soldati, Mr. Polak, Professor Szaraf, and Dr. Rozmus. Thank you one more time, and please let's now proceed to the next panel discussion, which is Challenges for Climate Protection, Environment and Modern Energy. I would like to kindly ask Professor Sebastian Werle, who is the coordinator of this priority research area, to start this. Thank you so much, and again, I wish you a very fruitful discussion.
Thank you for the invitation. Thank you. Bye-bye.
The topic of this panel is challenges for climate protection and environment and modern energy. And for me, it's a big honor to present all panelists. So I'd like to present them. First of all, I'd like to present Professor Ryszard Białecki, who is a professor at Silesian University of Technology. He is a corresponding member of the Polish Academy of Science. He was a vice rector for international cooperation in our university. Now he is a chair of section of thermodynamics of the Committee of Thermodynamics and Combustion of the Polish Academy of Science. The second panelist will be Professor João Castro Gomes, professor from the University of Barra Interior. He is a leader of the Center of Materials and Building Technologies Research Unit. He is a member of International Advisory Board of our POP6. The third panelist will be Professor Ewa Diamadopoulos. He is a professor at Technical University of Crete. He is a rector of that university. He is also a member of International Advisory Board of our Priority Research Area 6. The next panelist will be Professor Tomasz Gałka. He is a director of the Institute of Power Engineering Research Institute. He is also a member of International Advisory Board of the Priority Research Area 6. The next panelist will be Dr. Ilka Hajdas. She is a senior research scientist from Swiss Federal Institute of Technology, Laboratory of Ion Beam Physics. She is also Deputy President of the Division of Climate, Past, Present and Future of the European Geoscience Union. She is also a member of International Advisory Board of the Priority Research Area 6. The next panelist will be Professor Helsi Orlande. He is a professor at Federal University of the Rio de Janeiro. He is member of the Scientific Council of the International Center of Heat and Mass Transfer. He is also a delegate in the Assembly for International Heat Transfer Conferences. He is also a member of International Advisory Board of the Priority Research Area 6. And the last, but of course not least, panelist will be Professor Pastuszka Józef. He is a professor at our university. He is a vice director for science of the Center of Climate and Environmental Protection. He was also head of the Department of Air Protection in our university. And the moderator will be, the moderator of the discussion will be Dr. Marcin Grzegorek. He is a director of the Project Management Center at the Silesian University of Technology, whom I would like to thank for accepting the invitation for moderating this panel. So, Doctor, I give you the floor and I wish you a fruitful discussion. Thank you very much.
Thank you very much, Professor. I'm truly honored to start this panel, and I'm happy that you have already presented our distinguished guests. From the lists of the guests and from their activities, we can see how wide and how complex is the issue of the priority research area connected with the climate and environmental protection together with modern energy. There are really many issues. It will be really difficult to fit them into 45 minutes. So I will try to not extend my introduction, and I will ask Professor Ewa Diamadopoulos, Director of Technical University of Crete, but also our dear partner in Eureka Pro European University, which follows, as we defined, two SDG, United Nations Sustainable Development Goals, 12 and 4. So I would like to ask you, Ivan, as experienced educator, as the person responsible for important university and the person who's involved in many international actions, how do you think, what is the role of academia, of university in fulfilling the sustainable development goals defined by United Nations?
Good afternoon, and thank you very much for the invitation. I'm very happy to be here for this very, very important meeting, and looking forward, of course, to further cooperation with for university in the framework of the European University Alliance that we're all partners. Well, according to the United Nations, the 17 Sustainable Development Goals are the blueprint to achieve a better and more sustainable future for all. They address the global challenges we face, including poverty, inequality, climate change, environmental degradation, peace, and justice. Universities, on the other hand, are the primary institutions for the dissemination of knowledge through teaching and the generation of new knowledge through research. And these aspects make universities essential players in achieving the Sustainable Development Goals. By definition, universities fully match the targets and priorities set in the fourth SDG, quality education, which calls for inclusive, equitable, and quality education. Through innovation in teaching and research, through active participation of all academic stakeholders, teaching and research staff and students, the universities should encompass the vision of the SDGs and respond to the problems set out in the 2030 agenda. I would like to put forward 3 ideas that I would like to share with you. The first one is, as universities, we have to incorporate all aspects of the SDGs in the university curricula, thus providing students with the knowledge, skills, and scientific culture necessary to address the complex challenges of sustainable development throughout their careers. Many programs of study, such as the ones in my own department, environmental engineering, have already incorporated courses or academic directions towards specific SDGs. For example, the SDG 6, clean water and sanitation, or SDG 13, climate action. However, we need to take further interdisciplinary and transdisciplinary approaches. These are necessary. Therefore, technical universities, such as my university or your university, should develop, amend, and implement curricula towards a new engineering principle, sustainability engineering. The second idea is that university government bodies should adopt policies and implement strategic actions to address the SDGs. In addition to quality in education and research, these policies should target gender equality, appropriate environmental management on campus, moving towards a carbon neutral university, cooperating with the local communities to promote sustainable goals, building a culture for responsible consumption and production, which is actually the theme of our European University Alliance, making room for minorities and handicapped citizens. To give an example from my own university, we have practically eliminated the use of fossil fuels for heating and transportation. We only use electric vehicles or electric energy. We're renovating our buildings to achieve high energy efficiency, and we're building a photovoltaic facility. And the third idea is that we all live in a global environment: physical, economic, cultural, technological. To paraphrase an English saying, no university is an island. Globalization requires global cooperation, not only among universities, but also among national and transnational institutions, corporations and businesses, as well as local communities on a wider scale. Universities in the developed world and in Europe in particular can play an important role to provide, to meet challenges related to SDGs and to provide training and professional skills in the development world. Only when we work all together from different countries and cultures, from different disciplines and capabilities, we can make our universities leaders in the global process change.
Thank you very much. Thank you very much. Thank you for this introduction to many important issues connected with environmental protection. There rise a question, really. Shall we, this is a bit perverse, maybe not really politically correct questions, maybe a bit seditious. Shall we fight with the global changes of the climate, or we should adapt to that? I would like to direct that question to Dr. Irka Hajdas. Could you please tell us if we should fight against changing of the climate, or we should rather adapt?
Hello, everybody. Thank you for the invitation and this question, provocative. Maybe I would answer quickly. Actually, I think both. We have to do both. First of all, we have to adapt because we are so late reacting to climate change or climate warming. As you know, for the last decades, we kind of wasted time with activities like now. If we were doing this 40 years ago, maybe the world would not need this urgent call. What do we do now? And I really think the activities have to go in both directions. First of all, and I see how much the industrial technological development is so promising, probably helping us to adapt. But if we are looking at the records, and next 2 weeks, we will be in Vienna for EGU, for European Geosciences meeting. That is science showing us where we are with our situation now. And we all agree it doesn't look good. So what do we do? How do we stop this? This is, I think, an urgent question, not only to scientists, because we kind of, we can look into this, but the answer has to come from the society and from technological, political decisions. I think for the important directions are given by IPCC reports, and I see that there are coming with new reports this year and next year. I personally have to confess that I never looked into those issues so deeply, even before knowing all what we know from the past climate records. We knew the change is important, but we didn't feel obliged to bring those issues to the society. And I think now it's time to change that and be involved in such reports, such work like the reports of IPCC to inform ourselves and inform the society. That message has to go out to the society. And Professor Dimadopoulos, sorry, I just stated that perfectly, that we have to really bring this to our students, to our schools, to educate new societies to realize how dramatic situation is. If we look, I just browsed through the reports that are already out there for everybody to look at. And if we look at the change that is presented, desertification, it's not only climate, it's not only temperature that we are facing in Poland. I mean, I come from Poland, so I hear of those worries of people that they know we worried how it will be with water in the warming climate. So I think the answer is we have to go for both, and we have to really call this as an urgent task for all of us. Yes.
Thank you very much for this very pessimistic from one side statement. As I said, from one side it is pessimistic, but from the other side it's really better to know everything. It's better to be prepared and be conscious, of course. And as you have suggested, not everything is lost. So some changes, I understand, are inevitable, but from the other side, there will be some chances for us to protect what we already have or what we already had, to restore it. And well, in this spirit, I would like to ask Professor Pastuszka about the protection of the air that we are breathing. So what would be the next steps? What are the new priorities for the air protection? Professor Pastuszka, the floor is yours.
Yes, Mr. Chairman. Good afternoon, everybody. Yes, very shortly speaking, I'd like to say in the beginning that everybody agrees that the emission of air pollutants should be significantly reduced. However, a realistic scenario requires action in line with certain priorities. And these priorities should be clearly defined for every specific country. And I imagine that also we try to define maybe the common priority for group of countries, even for all the world. In the beginning, I'd like to say that we should divide the priorities into two groups of pollutants. First group, it would be pollutants strongly influencing human health. And second, pollutants responsible for the climate changes. Sometimes we have some misunderstanding. Some people thinking that, for example, reducing the emission of SO2 or particles, at the same time we're reducing the climatic changes. However, we should clearly indicate that in two groups of for different effects, we have two different groups of pollutants being responsible for this effect. And for the adverse effect are responsible mainly toxic pollutants like SO2, NOx, and something like this, carcinogenic pollutants, for example, benzoylfapyrin, allergens, airborne particles, aerosols. Aerosols should be classified as a different kind of pollutants for some reason, doesn't matter. On the other hand, when you're talking about the pollutants responsible for the climate change, everybody knows that it's mainly CO2. Hence, this is a problem because in the beginning, for example, in our region, in Upper Silesia especially, we had a great problem with the emission of toxic and cancerogenic pollutants, and we made a number of efforts giving as a result we received good results. We really reduced the emission of these pollutants. Of course, we still have a problem with the emissions of cancerogenic and toxic pollutants from so-called lower emission sources, like from individual stove or something like this. But we really reduce the emission from the industrial plants. However, achieving significant success in reduction the emission of toxic and cancerogenic pollutants from industrial sources, we neglected the reduction of carbon dioxide emissions. It will be said, however, that this is not an easy problem to solve. And frankly speaking, not only in Poland. A certain project in this area initiated in Poland did not bring the desired results. Hence, we can say we need some radical solution, and we should start discussing about it. Yes, but again, it's not only Polish problem. I'd like to mention that according to the information from Dr. Bill Leinach from American EPA, I just received a message from him some days ago. He said that he wrote me that the coal combustion's carbon capture research related to global warming was cancelled several years ago. Hence, we can see that even in the United States during the last some years, they changed their priority. We had similar project in Poland, and also we received no success in this field. Hence, certainly, we still should discuss about the priorities. We can say that in universe, it seems that coal for electrical generation is very much in decline, being replaced primarily by natural gas and renewables. Well, so our priorities must be changed, but again, we should discuss about our priorities. Certainly, in the beginning, in a number of countries, we should rather concentrate on the reduction of emission from pollutants being responsible for human health. But maybe in the next stage, we should concentrate rather on the reduction of emission of CO2. Maybe in some countries, we should concentrate on the both reduction at the same time, both group of pollutants. It depends on the country. I think that maybe it's a good time to organize some panel for the future discussion about these priorities. And I think that's that's another problem is to define the common priority for all countries. I think that we can agree that a common priority for all countries will be to reduce emission from the road traffic and from plane jet. I can say that after the discussion with my students from abroad, we can find that emission from traffic with high density is a common problem in different cities, in Stuttgart, in Karachi, and Sao Paulo in Brazil, and everywhere we have a very important problem related with the emission from traffic. And maybe it would be one common priority to reduce the emission from traffic. And second, certainly would be the reduction emission from the from plane jet. Germany was the first where this problem started to be discussed. And as you know, quite recently, President of France decided maybe very soon French people will travel inside the France only using train rather than plane. Plane should be used, jet planes should be used only to travel outside the country, outside the France.
Thank you.
And yes, I just finished. Hey, I only want to stress that I think it's very, very important to start discussion about the priorities to better organize our all technical action. Thank you.
Thank you very much, Professor. Thank you very much. I would like to ask Professor Castro Gomes from Portugal about his experiences. Perhaps he can tell us something about the capture of CO2 and involving this material into construction material in context of circular economy. João, can you join us and comment?
Yes. Thank you very much, Professor Marcin Grzegorzek, for your question. Good afternoon to all of you. Well, let me say, first of all, it is a pleasure for me to be here. I'm very honored for the invitation and the possibility to share with you some of my ideas and also obtain from you your ideas. Well, first of all, I would like to say, Professor Grzegorzek, that well, before that, before answering your question, I would like to say that we all know that with circular economy, we want to change from a linear model in which we are based on a model that is a linear, that is take, make, waste, to a model that dissociated from growth, from economical growth, and just consumption of resources, of natural resources, a model in which we know that our resources are limited, are finite, and we must think of regenerate our resources, regenerate, restore, reuse. And this is a radical change of thinking for all of us. As you said, I am a civil engineer. I work with building materials. From many years, I've been, let's say, used to heard about building materials, materials that are made from, obtained from nature resources, particularly cement obtained from clay and limestone. And these materials are finite, let's say, and we cannot continue to use it as it is. So we must reframe our ideas and view the wastes as a resource, as well CO2, as you brought very well to this discussion. Well, CO2 is like other waste materials. It can be a resource to make new solutions, new building materials, and to solve problems related with waste as well. So if we capture, by one side, if we capture CO2, we are helping to reduce climate change effects naturally, but as well, we can use CO2 as a resource to make new solutions, particularly to make new building materials. But the stage where we start to use CO2, to get to this stage, we must understand the concept of circular economy. This is why I want to start with that, because the concept of circular economy, maybe it will be too complex for people that are listening to us to understand why I start immediately to talk about CO2 and reusing CO2 as a civil engineer. Because the concept of circular economy is not only to, let's say, to value the cycle of one sector only, because it is in fact a complex problem, a multi-sector problem. So when we start to look to the wastes as a source materials, as a new raw materials for different sectors, we understand that the circular economy is not only limited to one sector and not only limited to environmental protection, let's say. So we have the experience, as you mentioned, of using CO2 in our research, because with CO2 we can make certain types of wastes can be hardened and can become binding materials, can becoming cementitious materials. Well, maybe it's enough for now to start. I don't know if I answer your question.
Yes, thank you very much, Professor. I hope we will still have many chances to talk with you about these issues. As you know, these are crucial issues also for us here in Upper Silesia. I hope we will be able to talk about it. I would like now to switch into the second group of issues that the priority research area at SUT concerns or refers. It means the energy. So I would like to ask Professor Helsio Orlande about new applications of renewable energy sources.
Hello all. Thank you, Professor Gorski. Can you hear me?
Yes, we can hear you. Thank you.
Oh, okay. All right. Okay. Well, it's a great pleasure to be here. Thank you for the invitation, and I'd like to share a little bit my thoughts about the new renewable energy sources. And the reason why I have chosen this topic is because Poland's energy policy for year 2040. It has the development of renewable energy sources as one of its strategic goals. So Poland wants to build about 20 gigawatts of photovoltaic panels and 10 gigawatt from offshore wind generation by 2040. And actually, there is a great potential for wind generation in Poland, especially in the Baltic Sea. And in fact, Poland is one of the signees of the Baltic Sea Offshore Wind Joint Declaration of Intent. The potential for photovoltaic power generation in Poland is also good, and especially the south of Poland, include the Silesian region. And of course, it's all, when we talk about renewable energy sources, we always think about the mismatch between the supply and the demand. And recently, there has been a lot of interest on the use of hydrogen as for energy storage, and also as an energy carrier. And this has not been only like a research interest, but actually multinational projects, European projects. And there are many possibilities for the use of, for the application of hydrogen in the industry, in transport, in power, in buildings. Hydrogen does not emit CO2. It's considered as essential to support the European Union commitment to reach carbon neutrality, and also to implement the Paris Agreement towards zero pollution. It can also provide some flexibility to nuclear power plants, like Poland also plans to build a nuclear power plant, because they commonly work with a high load factor, and so energy not utilized by not consumed by the market can be converted into hydrogen to be consumed later. Hydrogen can be transported in small concentrations mixed with natural gas in existing pipelines, but there is also the possibility of constructing new pipelines or even refurbishing old ones. And storage can be done in salt caverns or empty gas fields, and there is also a great potential for storing hydrogen in Poland. The technology for electrolyzers is commonly available, is commercially available nowadays, and but there is still great interest on, for example, in the development of electrolyzers for the direct seawater electrolysis. And also when you consider that we can generate hydrogen directly from the sun irradiation. And there are two routes on this way to produce hydrogen, which is the thermochemical water splitting or the photocatalysis. This is still at the research level. And I have listed here a couple of technical challenges and open problems that would be of great research interest, starting from optimization of the whole hydrogen chain. And this, of course, includes exergetic analysis, and where with my good friends from SUT, they are worldwide known as experts to on this topic. Optimization can also be considered at the equipment level. There are some technical issues about the storage and combustion of mixtures of hydrogen and natural gas, the development of synthetic fuels. Of course, this would involve multi-scale modeling and computer simulations of physical chemical phenomena and the development of new materials.
Thank you very much, Professor.
Well, I conclude here, and again, thank you very much for this opportunity to be here. It's good to see some good old friends, even by distance, in this small screen. I stop
Thank
here.
you.
Thank you.
Thank you very much. I would like to address the next question to Professor Gałka. What is the carbon neutrality, and how can it be achieved by 2050?
Good afternoon, everyone. It's really a thrill to be here, and it's an honor for me to visit such a distinguished company. Well, carbon neutrality, decarbonization, first we should start with defining this, because I don't think there is a widely accepted definition. In the strictest sense, decarbonization means reducing carbon dioxide emission from all fields of our activity that are not natural. This is understood as a return to good old days, to paradise lost, when our ancestors lived in trees and life expectancy was about 25 years or so. Of course, this cannot be accomplished. So in more reasonable manner, decarbonization may be understood as, well, let's say, eliminating carbon dioxide emission from all forms, all manifestations of human activity other than breathing. Unfortunately, recently, carbon neutrality and decarbonization has become not only technological, economical, but also a political issue. Politicians used to promise us, especially right before elections, they used to promise us, well, better wages, better health protection, lower taxes, peace, and safety, and so on. Now they also promise clean environment. To make things even worse, there are some, let's call them prophets. Some of them say, well, the disaster is close. Some of them say disaster is right now. And some of them say, well, there's nothing to worry about. There's nothing we can do about it. So in such situations, there is much emotion about decarbonization. And I think that many of us have some specific concepts about it. Of course, carbon neutrality is the issue of mainly power industry. And power industry is understood quite logically as the greatest source of carbon dioxide emission. Of course, there are also other sources which are also important, but to this I will return in the end. Can carbon neutrality be achieved by 2050? From the theoretical point of view, the answer should be yes, it can. But look at this in a more reasonable manner. In my opinion, carbon neutrality in power engineering, in power generation, I mean, has three basic components. It's nuclear energy, it's renewables, and carbon dioxide capture, storage, and perhaps reuse, because storage capacity by itself is limited. As for nuclear energy, this is well-developed technology, or technologies rather, which are used all over the world. Contrary to what is often said about the technologies are safe and they are ready for application throughout the world. As for the renewables, we often think that renewables are an alternative to coal, but we should keep in mind that, for example, burning biomass, pellets, burning natural gas, we also generate carbon dioxide. Maybe in a less spectacular way than from coal, but we also do. So in practice, the only renewables that generate no or almost no carbon dioxide are photovoltaics and wind energy. Both of them are unpredictable. So in order to integrate such sources into a power supply system, we have to provide quite large capacity for storage, for energy storage, and in this I see potential. It's not only potential, no, it's now being developed. The field of application for hydrogen technologies in a wide sense, of course.
Thank you very much, Professor. Thank you very much. I would like our last speaker, Professor Ryszard Białecki, to sum up what has been said, especially in the context of the future of the energy.
Thank you, Marcin. Can you hear me?
Yes, we can hear you well.
So that's really a difficult task, because I have to wrap up a discussion on circular economy, on climate changes, new energy technologies, air pollution, and decarbonization. So it's like looking for a philosophical stone.
Yes, and the worst is I have to ask you to sum it up, let's say, in a really short time. Thank you.
Okay. Well, there is no doubt about the coupling of the policy, the political rules, and energy questions. Actually, all the changes that have been introduced in the development of the energy strategies, and also environmental protection, they have been enforced by politicians. So they introduced certain rules that, especially within the European Union, we should adhere to. And well, I would like to mention two of these rules. The first is the European Green Deal, which is a set of policy initiatives, and you can treat it as a roadmap to sustainable economy. Again, sustainable economy is a buzzword, but it is widely used. And the aim is that at 2050, where the economy in the United Europe will be climate neutral. And the measures to reach this task will be, well, already are. First, the emission trading system. So the trading system concerns, first of all, the power sector, but also the industry and transportation. And an important role to play is the energy efficiency. So the energy efficiency, which again, actually is a buzzword because it is not a well-defined term. What is an energy efficiency? But there is no doubt that we have to improve the energy efficiency, because the best way to reduce emission is the energy economy. So we have to save energy. And also, well, within this is a small chapter that we have to turn to cogeneration of heat and power. Another regulation that has been introduced is the land use change and forestry. So this concerns the absorption of CO2 from the atmosphere that should be balanced with the emission of the energy of CO2 generally from agriculture. There is the new approach here is that we include here into the balance of CO2 not only the forest, it was before, but also all the land use. So the aim is that we have to reach the no debit rule. So the amount of CO2 that is absorbed, it should be equal to the amount of CO2 that is generated.
Thank you very much. The schedule is really tight. I'm really aware that we are not able to touch all of the subjects and to sum up even what has been announced here. I would like to thank you and all of our distinguished panelists for joining this initial conversation, this initial panel. I do hope, I'm quite sure that we'll have many opportunities to dig more and develop all of the issues that has been only signalized here. I realize that this is very complex part of the problems that the humanity encounters at this moment. Thank you very much. I return my floor to Rector Pawełczyk. Thank you very much.
Thank you. Goodbye.
Goodbye.
Thank you and goodbye.
Bye, Ivan.
Thank you very much. Thank you very much for this discussion on challenges for climate protection, environment, and modern energy. Thank you, Dr. Górski, for moderating the discussion, and thank you for participation addressed to Professor Białecki, Professor Castro-Gomez, Professor Gałka, Professor Hajdas, Professor Orlande, and Professor Diamadopoulos, and Professor Pastuszka. Thank you one more time. And now it's the time to start a discussion. So every participant of today's meeting is welcome to ask questions. We can address the questions to all the presentations and all the panel discussions. So now the floor is addressed to the audience. So you are welcome to ask.
Maybe if I wanted to add something at the very end.
You're welcome.
So after my panel, I had a few phone calls, maybe not questions, with the suggestion of organizing new meetings devoted to the software, which was very briefly presented during my panel. So I welcome you to priority research area number 5 for separate meetings, especially devoted to Gaia and to Nazca. Welcome all of you.
Thank you very much. Are there any other questions or ideas to share? We heard a number of very important problems being discussed concerning all of our activities in terms of topics, obviously, because we couldn't mention and couldn't address everything what we are doing at our university. As you could notice, I address mostly these words to our guests. We are an active university, and we dare to address really important problems, try to form important hypotheses for the time being. So perhaps the panelists could try to add something more. Would you be willing to say something, because you had the possibility to hear to also other discussions on different panels? You may have some ideas, or you would like to share any information with us. I'm encouraging you to.
Yeah, I would like to ask a question. Maybe there are still some experts in artificial intelligence with us. I was very interestingly following the second session. And well, I'm being asked many times a question towards, this is a critics towards artificial intelligence, actually. And this is such a critics that even comedians in Germany are laughing on artificial intelligence all the time. And to be honest, I sometimes I don't know what to answer. And the critics is that actually artificial intelligence algorithms are very good in recognizing things that have happened in the past. So you have to have a lot of examples from the past from something. Then you are able to recognize things that the system already have seen in the past. But what about extreme events, completely new events that haven't been seen in the past? Of course, we have some techniques like transfer learning and so on. So maybe you can go a little bit above what you have seen in the past. But actually, do you know any strategies or any working theoretical foundations towards modeling extreme events in machine learning and artificial intelligence?
Maybe I will answer this question. Of course, you are right that artificial intelligence is better when something what happened before happens now. Yes? But in fact, we can say exactly the same about humans. Humans are better in saying, oh, what happened, predicting what will happen if something like this happened before. Yes. So maybe it's another clue that the artificial intelligence is really similar to human intelligence. But what are the problems? This is generally the obvious and the most important problem of artificial intelligence, that we want to create a model that is generative, that may predict something. It's very easy to create a model that classifies images when it knows the images before it was created. It's trained on these images. But to create a model that is trained on one set of images and then is able to classify another set of images, it's much more difficult. It is possible, but of course it's difficult. And the same maybe said about every data set. And so it's true, but generally it's just a property of artificial intelligence and maybe of intelligence at all, that we are better in predicting something when something similar already happened.
Okay, thank you.
Yeah. Okay, maybe I can add something. I don't know whether I answered your question. I mean, to Professor Marcin Grzegorzek, but well, at our university, at some faculties, they work groups, people who work on detecting anomalies, and it is something which was not known before. However, it is it is well known, so I wouldn't like to explain it to everybody, but it is like the difference between classification and clustering. In the first case, we know the example, yes, we have a teacher, and in the second case, we don't have. And in Polish, it is maybe even easier to understand because we have a word rozpoznanie. And to rozpoznać something, we have to poznać something at first. So then we build something from well-known things, like, for example, Pegasus. Yes, it is a horse with wings. And these two things are known to us. So, but answering, because I understood your question that you ask whether at our university are people who work on prediction and something in artificial intelligence. Yes, of course, Professor Paweł Kasprowski, for example, and his group. And I'm from mechanical engineering, and maybe we are focused mostly on technical diagnostics, but yes, we apply artificial intelligence methods to different examples which are quite new and unknown. Yes, and we look, generally speaking, anomalies. Yes.
Hello. May I ask you a question?
Can I ask a question?
Yes, you're welcome, please. Absolutely.
Yeah. For the artificial intelligence, this type of methodology for predictions based on history, statistics, and so forth. In my opinion, or let me add it as a question, do you think that without collaboration, in order to build a prediction tool for things are happening, we have to consider also that the prediction can be wrong. And this wrong prediction has to be communicated to all the people who are using artificial intelligence. Now, if that, so the best way then, in my opinion, as a suggestion, I'm sure there are other ways, but to have a kind of global center where, let's say, specialized in medicine and mechanical, different disciplines. And those centers are responsible for taking the failure of prediction, the scattering of data, all these type of things that can affect the prediction. That centers would be responsible for spreading information. Of course, we have also publications, but as you know, publications, unfortunately, in most cases, give the successful prediction, the successful experience, and usually not the failure. So we have to make sure that if we to develop artificial intelligence in any area, we have to make sure that collaboration from data collaboration and everything to be put in one part. Let us look at what happens with the corona. This is an international problem. How much collaboration between the different companies, different countries, so forth, in order to get the vaccines that could work, I would say very minimum. And what is the result of that? The result is that there are some developed vaccine. Europe has to eliminate because of the deaths, so I think we have to take this experience also when we are developing artificial intelligence for predicting cases. So that is my comment and question.
If I may just shortly answer, I don't think that there is a big problem with communication now between researchers working on artificial intelligence or anything, because of internet, of ArchiveX, and many places where the results are available, or GitHub for computer scientists. I'm teaching my students algorithms that were developed and published 2 years ago. So before they started the studies now. So we are very fast in exchanging information. So I don't think it's a problem. There are other problems. Of course, there are publicly available data sets and so on. But you, of course, are right that it's much more difficult to publish the results that is the report of a failure. Yes. But I've managed to publish some papers that were describing my failures, yes? And it was something which could be valuable.
I think the failure can contribute as good as
maybe it's even more.
Even exactly. And I was a defending or opponent for one of the PhD, and it was showing all the success. So when you start to ask questions, there are failures, but it's not documented. And that's dangerous that we are facing, I guess. But thank you for your answer.
Thank you very much. And I can see that Professor Hajdas is going to ask the questions. You're welcome.
Okay, thank you. I should put the hand down now, later. Actually, I would like to read the question or support the question of Artur Góra, who wrote in chat. That is a question, a comment, asking about the strategies. You know, I am interested in climate change. I'm not so pessimistic, but I think the situation is urgent, and we really hoping for initiatives that are common, not only scientists ringing the bell, but also industrial and political collaboration here. So I think that Artur, I will not read the whole question, but he's stating this perfectly. What are we going to do here? Because I see you have in the panel great examples, Professor. I'm sorry, I cannot read perfectly the name. Diamadopoulos said their university is energy free, zero, using CO2 emissions at level 0. And I must say, maybe that will sound a little funny, but when I saw the title Industry 4.0, I was thinking this is like the teenagers now say Industry for reduction of CO2 down to 0. And this is how I imagine our future should be going, focusing on this, how we reduce the past, that our sins from the past to the level that the whole globe can function and can go into, I think, example with the not more linear economics, but the circular, or as people say, donut economics. It's a perfect example that we could give more thoughts. And also the idea of recycling. I know in Switzerland, there is so much construction going into using new materials, where the places for dump of the old material is also sparse. So we're wasting so much of resources here. So really, this is something that I cannot answer questions of Artur Góra, but I think those are very relevant issues here. Thank you.
Thank you very much. I would but I'd like to comment on this very important problem. I think we all can read the questions of Professor Artur Góra. The first one is what kind of activities we can apply to truly decrease the gap between Poland and rest of Europe. And the other is how, as a top university in the one of the most polluted region of Poland and Europe, we can contribute and provide an example of transformation to green, nature-respecting society. So,
may I say?
Yes, you're welcome, please.
Marek?
Yes, you're welcome, Evan.
Okay. These are very important questions. And first of all, let me clarify, we are not a carbon neutral university, which just have eliminated the immediate use of fossil fuels. We use electricity, but not all electricity comes from renewable energy sources. Here on the island of Crete, I think something like 40% comes. So, but we hope maybe in 10 or 15 years, the entire campus and the entire island of Crete will be maybe carbon neutral. But I think there are a lot of things that, we found out is that it is very important to understand for us that, Greece went through a financial crisis. So we had, our primary motive was to try and run the university by trying to save money. And we found out that there are ways of saving money for the university and at the same time creating conditions moving towards a green university. But here on the island of Crete, in the south, in the Mediterranean region, we have a lot of sun. So, we can it is easy for us to install, let's say, photovoltaic panels and have the production of clean energy. Each university, for instance, will have to identify, the challenges, and then it is very important that you develop a strategic plan towards this direction. It's not going to be an easy road, but I think there are a lot of challenges, and because we're technical universities, we're engineering universities, we have all the technical engineering tools, and then we can implement this thing much faster than other areas.
Thank you.
Well, if I might say something too.
Yes, you're welcome.
Okay, thank you very much. Well, in your regions and other regions of the planet, there is a lot of waste, mining waste, industrial waste, all sorts of waste. And I think a solution to tackle this problem is to look to the wastes as raw materials, as minerals that can be used for other purpose. But we have to ask the questions, have to question what the use we can give to the waste, not only for, let's say, the industry, that's not as a value for the industry that is producing these wastes, but for other sectors, for other industries as well. If we do that, I think we can, let's say, develop new ideas and start new business ideas. We can find new solutions to use the waste. Wastes are elements, are minerals, or organic or non-organic. Well, and they have chemicals on it. So they are calcium, magnesium, silica. In some industries, the best way is to take out some of the minerals and use it for other purpose. While in other approaches can be to blend the wastes with other types of wastes, to consolidate it, or to make it into smart materials, into smart applications. So to give value to the wastes. And not only looking at wastes as solid wastes, but not only combining solid wastes, but also combining solid wastes with liquid wastes and gaseous wastes with CO2 or methane. So I think this is the right way to tackle this problem, is to see, is to start thinking that a circular economy is only about a circular value of a sector, but to think about that circular economy, it's a circular value of different sectors. Okay, so can you grow, for example, can you grow plants on your wastes? How can you change your wastes so plants can grow on it? Can you make your wastes energy harvesting? Why not? So give values to your waste, to your pollution, let's say, and well, not only to your pollutions, but other places pollutions. If we can do that as scientists, well, we can reproduce the solutions to different parts of the globe. So I think this is the challenge, the main challenge we have to develop. Thank you.
Thank you very much. I think that we could continue our discussion. It's really interesting, and this is due to the fact that we've gathered so many outstanding scientists and practitioners. But we are approaching the end of the conference. We need to know that today is Friday and everybody needs to rest before the next week comes. So thank you one more time for participating. Thank you for all the discussions and also acquiring this experience from our outstanding guests. I appreciate your participation and discussion very much. So thank you for your contribution, and I wish you a nice evening, wonderful weekend, and great health, first of all. Thank you so much. All the best.